Hello everyone. Uh, I hope I am audible. Okay. Yep. Hello everyone. So today is the day 2 of Fire 2020, and we will start with our sessions for today. So today's next session is on sentiment analysis of Dravidian languages in code mixed text. We will have the track presentations of this track, and I hand over now to the track chair, Bharti Raja Ashok Chakravarti, to take over. Thank you. Over to you, Bharti.
Thanks, Supendra. The first presentation will be the SSN NLP MRLG group. The title of the paper is Sentiment Code Mixed Text Classification in Tamil and Malayalam using ULM FIT. The presenter is Thenmozhi. I am unmuting her. And Thenmozhi, you can start presenting. You have 10 minutes.
Okay, sir. Can I share my screen?
Yeah, you can share your screen.
Host disabled participant screen sharing is I'm getting that.
Okay.
Now you are host.
Yeah. I will try now. Okay. Is it visible, sir, my screen?
Yes, thanks.
Fine. Very good afternoon, all. I am Thenmozhi from SSN. I'm going to present our work, Sentiment Code Mixed Text Classification in Tamil and Malayalam using ULM FIT. And the main objective of this work is to detect and classify the sentiment message polarity in Dravidian code mixed languages, that is Tamil with English and Malayalam with English, from social media comments. And we used supervised learning method to detect the sentiments. And we supposed to classify the given tweets into 6 classes in Tamil and Malayalam code mixed languages, namely that is the classes positive, negative, neutral, mixed emotions, unknown. And in case of Tamil code mixed, we need to classify whether it is non-Tamil, and in case of Malayalam, we need to classify that into non-Malayalam. So this is the task given. And we know that the sentiment analysis is computationally identifying and categorizing the opinions expressed in piece of text, which determines whether the attitude of the user is about any topic or product to be positive, negative, or neutral. And examples of positive sentiment and negative sentiments are given here. I really like the new design of your website, seems to be the positive sentiment, and I'm not sure if I like the new design, seems to be the neutral sentiment, and the new design is awful, can be the negative sentiment. So it's this kind of sentiments needed to be analyzed. And it is very important to analyze this sentiment due to increasing usage of social media to determine the marketing strategy, campaign success, product messaging, and to improve the customer service also. And in this challenge, in this shared task, we have been given a multilingual or a code mixed language to identify and categorize the sentiments from Tamil and English combination of text and Malayalam and English combination of text. And these are a few examples. Thala, Mass, UB, GM, Vera level seems to be the positive sentiment. Likewise, if you see this particular text, it's a mixed of sentence are given in English, but the words vocabulary comprises of both English and Tamil. And when we process this, we found a few challenges. It is very difficult to transfer the code mixed into native language, and the data is balanced, and the sentences are ungrammatical, and many non-vocabulary words we found, and usage of slangs also were there. And the native language, whatever is there, is given in Roman format, and a lot of prolonged word or star words, or so many noisy words are there, and it is very challenging for us to process them. And this is the data given by the shared task. And I don't that is, I'm not going to be detailed in these data and all. This has been given in the overview paper. And training, that is, we have been given training instance, validation and test instances for both Tamil and Malayalam languages. And this is the distribution of both the language text with respect to all the 6 classes. Okay, so this is the distribution, and if you see this distribution, it has not been uniformly distributed. If you see the positive sentiment, there are almost 8,000 and odd things were there, and all other classes are not equally balanced. So that is one challenge we find in this text. And what is the methodology we used? So the first step is pre-processing. We have used the NLTK library to pre-process, and we have removed some strings that starts with @symbol. They denotes the user, and knowing about the user is not contributing to the sentiment, so we have removed the text with @symbol. And we removed the hashtags, punctuations, URLs, numerals, all these characters, and few emojis also were removed, and we converted the uppercase text into lowercase. So these are the various pre-processing steps we have done. And we use the ULM fit framework for implementing this sentiment analysis, and which is available in a fast AI library, which comes up in Python language. And these are various steps supposed to be done for ULM fit. Before getting into ULM fit, the data needed to be pre-processed, and we need to create the data frame for the input data, and we need to prepare the data for creating the or fine-tuning the language model. We need to prepare the data and to apply the classification model. And we started, because this ULM fit is the pre-trained model, and we need to fine-tune this model for the given data set. Okay, and we saved that into the encoder. And finally we fine-tuned the data, fine-tuned our model for the classification purpose, and finally we fit the model and we made the prediction out of it. So as I informed that this ULM is a pre-trained model. It has been originally it has been developed to create a language model which predicts the next word in a sentence. And this ULM fit model has been unsupervised learning model. And this model has been created by training the Wikitext 103 corpus. And the recurrent unit used by this ULM fit is just LSTM. And that this fast AI wrapper provides the classification, that is the ULM fit for the classification purpose. So what we have to do for when we use the fast AI, we need to create a data bunch which automatically pre-process the text including vocabulary and tokenization. And that is we need to use text LM data bunch for creating a bunch for data modeling. And we have to use text class data bunch for doing the classification. And the next thing is we need to learn the model by making use of the method language model learner. And using that we need to fine tune the model and fit that model for the given data. So that is initially when we fine tune the model. Maybe when I show the validation results, we come to know that normal fine tuning is not given much performance. So what we have done is we need to unfreeze it and change the learning rates, different learning rates and batch sizes for different languages, and gradually we freeze them. And finally what we get is the fine-tuned model after doing the gradual freezing. And that fine-tuned model is used to predict the data. And if the result, if we see on validation set, this ULM fit model before fine-tuning, we got the accuracy of just 0.25 for Tamil and 0.3233 for Malayalam. But after doing a gradual freezing by changing the learning rate and other things, we got the validation accuracy of 0.697 and 0.655 for Tamil and Malayalam language respectively. And this we have submitted as a run to the task. And that is when we evaluate this model for the test data, we have obtained the FN score of zero point 0.6 for both the Tamil to English code mix and Malayalam to English code mix. So this is our work and the results. And that is we have got the FN score of zero point 0.6 for both Tamil and Malayalam language. And in future we may change the parameters, or we may change the values of the parameters, and we can try for further results. And currently, as I shown, the data seems to be imbalanced, and we try to balance them by doing some downsampling or some augmentation of text, and then we can improve the results. So this is our work. Yes, sir. Yeah, this is about my presentation. Any queries? And I request the organizers to unmute my co-author. She's also logged in under the name Tenmuri D for the question session.
Hi, Tanuri. She is
Yeah.
also unmuted.
Yeah.
Yes.
Yes, thank you.
The presentation was very good presentation, and the work it was very good.
Thank you.
And I have one question. You said you have uncased. You converted the lowercase higher, like a caps letter, to lowercase
Yeah.
one. What was the reason behind it?
Generally some text, like if in case, because it's a code mix which comprises of both the Dravidian language and English language, there is no impact on converting the text into lowercase in case of our regional the Dravidian language. But as far as the English is concerned, maybe that is our set of vocabulary is needed to be determined. If we have not converted them into lowercase, both the the word with uppercase and the word with lowercase will be treated as two different entities in the vocabulary, and which is not required. For that reason we have converted them. But we need to we are supposed to measure the impact on converting them into lowercase. That actually we missed it. We should have done that.
That's interesting one, but this we have to we see people doing this in machine translation and other works as well.
Okay.
But my question is that the second question is like, did you deal with the named entities? Because in the name, when you are using the named entities, even in when we are writing in the transcribed Tamil script in English Roman script, we still use the named entity like a Tenmuri, the capital T, so that the named entity will have a certain information that might be useful. So this is data set about movie trailers, so they might be writing movie name and then explaining the sentiment about the movie. So did you think about keeping the named entity as it
as
is?
such? Yeah, we should have done that. Because I thought that this knowing of the proper names, or the named entities is not having much impact on sentiment, I feel. So that's why we change them into lowercase. Probably maybe we should have measured that what is the impact on converting them into lowercase and not converting them into lowercase. That we should have tried. Maybe we'll do that in future.
Okay, that's interesting one. Thanks. Claps. This is virtual claps.
Thank you.
Okay.
Thank you.
If
Thank you.
you
Thank
could,
you, sir.
yeah, if you could stop sharing the screen, we can go to the next.
Yes, yes,
Thing.
sir.
Yeah.
Yes. 1 second. Okay, I stopped.
Okay. Thanks. Sorry, I got confused with the Ireland time. That's why I think we started 30 minutes early. Thanks for presenting in the short notice. The next presenter, we will be going for the third paper, that is MUCS Dravidian Code Mix SACO Sentiment Analysis for Code Mix Text by
Fazlur Rahman. Hello.
Yes.
Yes. First, I need to share my screen, but still I'm not able to do this. Can you please?
Okay. That video. So
It's allowed. Hello.
Hello.
Hi.
You can share your screen now.
No, still I'm not able to share my screen. It's giving some error like has disabled participant to screen shading.
Okay, 1 minute.
Bharti, I think Judith is also ready with her presentation. She was pinging in the chat.
So that will be next.
Okay.
After.
Okay, thanks.
If it is not working, then we can present with Judith and then we can start. Fazlur, is it? Can you able
Hello?
to share?
No, still I'm getting error like has disabled participant screen sharing. I'm trying to share screen, but I'm not able to do this.
Okay, maybe.
Because maybe I need to be co-host.
You are a host now. No.
Not
Judith
yet.
Jeffra became the host now. So we will go to the Judith Jeffra presentation, then we will come back to you.
Sure.
Hello.
Hi. So the next presentation will be by Judith Jeffra. The title of the paper is Sentiment Analysis of YouTube Comments for Dravidian Languages. And the floor is with you, Judith.
Okay. Are you able to see my screen?
Yes. Yeah.
Great. Just start this slideshow. Okay. So I'm Judith, and I'm going to be presenting the task of sentiment analysis of YouTube comments. So in this presentation, the content is going to be as follows: a little bit of background, then some information on the corpus, and followed by some algorithms I have implemented, results, and a short conclusion. Firstly, for sentiment analysis, here is the process of identifying the tone of a given sentiment or opinion. That is to say, if the sentiment or the opinion or any statement for that matter is either positive, negative, or neutral without any other suggestions. So it's basically like a classification problem. So the task in this shared task was to classify sentiments from YouTube comments in a mixed Dravidian languages of both Tamil and Malayalam. So the corpus was a collection of YouTube comments in two different languages, both Tamil and Malayalam. The corpus was written in a Latin script that is with a code mix. So there were both a Latin script and also some comments had actual Tamil or a Malayalam script as well. So with respect to both the languages, Tamil and Malayalam, so I have put on the slide the actual instances of the training, validation, and test datasets for both the languages. The classes were positive, negative, unknown states, mixed feeling, or not Tamil for the Tamil dataset, or not Malayalam for the Malayalam dataset. Okay, then I go for a little bit of background before I do the algorithms. So I do a text representation here. Instead of, I convert all the um sentences which to be represented by a numerical feature vector. For this, I use the bag of words and the TF-IDF to convert into numerical feature vectors. In this work, I treat the problem as a multi-class classification problem. That is because we have multiple classes, and each statement should be classified into one or the other class. So we have multiple classes, thus multi-class classification problem. So I implement 4 algorithms: logistic regression, random forest, SVMs, and naive Bayes to see which one has the greatest accuracy in terms of the training set. And using this, I implement the model with the highest accuracy for the development and the test sets as well. So firstly, logistic regression. Oh, it's a very already well established. All 4 of the algorithms are well established ones. Here, I force the output layer to have discrete probabilities for all the classes that for each language using the softmax function. And here at this point, there is a necessity to impose weight connecting each input to each output. So I used the formula y equal to softmax of xw plus b to do this. A random forest. Basically, a random forest is a collection of a large number of decision trees. So with each decision tree, there is a prediction for a class as to which this statement to belong to which class. Finally, a vote is performed with all the decision trees, and the class which gets the maximum vote is declared as the output. Here, a random subspace I've used for the implementation. Then the support vector machines. It's basically to identify a hyperplane that will separate the various features of the task. So here I used a linear SVM with a one versus rest type approach. So basically, the idea is to split the data set into multiple binary classification problems, and then finally to combine all these problems, all the results into one. Naive Bayes. This algorithm is based on the Bayes theorem, where a posterior probability is calculated for each classification model, and the highest posterior probability is assigned as the predicted class. Based on this, I have implemented these algorithms on Python using the scikit-learn package. And here I have some parameters that I have altered for the task. Each model has been executed separately for the 2 languages, Tamil and Malayalam. Finally, the model with the highest accuracy was chosen to be implemented for the test dataset. Here on the right, I have the accuracy of each model for the two languages. It can be seen from the table that for Tamil, the naive basis performed very well with an accuracy of 0.69, closely followed by random forest classifiers with 0.67. Um, However, for the Malayalam dataset, it's the logistic regression that has the highest accuracy with 0.64 and SVM with 0.60. So for the Tamil language dataset, I use the naive basis model for the test dataset to classify the sentences in the test dataset. For the Malayalam, I use logistic regression for classification. With respect to that, we see the results of precision recall and F score for the test datasets in the table, the bottom on the left. The precision for Malayalam is quite high when compared to Tamil. This could be because of small data sets in the training set of Malayalam, but a huge data set for Tamil could be a result of overfitting as well. But analysis should be done for this purpose. So I conclude by saying that in this task, we did a classification of YouTube comments for both the Tamil and Malayalam code mixed corpus, which was treated as a multi-class classification problem, implementing several already existing machine learning algorithms, and choosing the model which has the highest accuracy for the test dataset. Thank you.
Thanks for the nice presentation, Judith. Before I ask question, can you please change the control to the host, make the IR lab to the host?
Hello. Please pass the host to me.
How can I do that?
Check the participant list.
Yes. Just a second. Yes, IR lab.
Yes. Yes. Go to the more and pass host. Or or just complete this presentation.
Maybe stop.
Leave it. Just
Okay,
complete.
not sharing my screen, but I have participants. More make host. Yes.
Thank you.
Is it okay?
Yeah.
Can I share my screen again, or is it okay?
No, it's okay. So the questions, I haven't. If anybody has questions, you can ask them. Meanwhile, I have a question, and the question is: you have used machine learning algorithms, the traditional machine learning algorithms. That was nice. But the baseline that we presented in our paper, also the paper for the associated data set, also we did the baseline models with the machine learning algorithms. My first question is, what's the difference between the baseline models and yours? And that the second one is, why you haven't tried with the deep learning models, and is there any specific reason, or do you believe that machine learning models are more suitable for this data set? So I want to know your thoughts.
With respect to deep learning models, that is one of the future works. It could be tried. I'm not sure how they will work yet, but within the given span, I was able to only implement this algorithms for.
Okay, that's fair.
So, but I should try to implement some deep learning algorithms as well for this task. Maybe it will work better. It's one of the future works. With respect to the baseline models, I think the difference is about the implementation. I have changed some implementation details on while using the Python to fine tune it for the task. I have given the implementation details on the paper, so I think that was the difference that I did.
Okay, We have a question from the audience, Tenori. She's asking, did you try any feature selection?
Sorry, did you try any feature selection? It was the automatic feature selection that was done by the Python, this scikit-learn package of the Python. I used that to do feature selections.
Okay. So that's the question. So, and another question is, how much improvement over the baseline?
I don't remember exactly the numbers, but there was an improvement, I think, with the precision and recall. I don't remember the exact numbers.
Okay. Okay. So we will go to the next presentation by Fazal Rahman. So can you share your screen?
Hello.
Yeah, can you share your screen?
Yes, I share now if it's visible for you.
Yes, yes, it's visible. Thanks.
Okay, thank you. Good evening, everyone. I'm myself, Fazal Rahman from Anglo University. I'm going to present my paper, Sacco Sentiment Analysis for Code Mixed Text. Okay, my next challenge is to for the next slide. Okay, since almost yesterday, a very huge introduction has been given by a task organizer and also two previous teams. So I'm not going to say what is Dravidian languages, what is code mix, and all this thing already has been presented. So just I want to go directly to my proposed methodology and what we have done during this competition. So first I need to explain what kind of features I use here. I use n-grams that actually all of you are much more better than me know what is n-gram sequence of n items like a child n-grams or word n-grams. But I use a combination of n-grams, then I give them to counterpart to be ready for feeding my machine learning classifier. Also, I use word vectors. Word vectors, as you know, is transforming a text into a vectors that we can say after transforming a similar words will be having similar vectors. And I given this one to deep learning models, and also I tried for a subword vectors. As you are familiar with n-grams and word vector and different kind of word embeddings, I'm going to explain the first about my subword vector. That's why I use subword vector in this task. Okay. So first, I for a short introduction about subword vectors, I need to say generally all NLP systems discard the words with words that are rarely seen in training corpus. So for example, you can see here one code mix word like Indiale, that is a code mix between, I think, English and Malayalam language. Okay, so if we are looking into this word in a word embedding or word vector, it's really been seen and maybe it will be missed because, for example, Indial is not a word in any language. It's not an English word, a pure English word, and it's not a pure Malayalam word. So what I wanted to do, I use byte pair embedding tools, which is available for many languages. So I use this byte pair embedding tools to encode this kind of words. I encoded this word, so it will split this word into two words. One is pure English and some suffix. This suffix, if what subword give us, actually subword allows us to finding parts of words that that are seems to be unknown unknown or out of vocabulary. For example, some words are, if here this is India lay. India lay is maybe only one time we can see it. If I split it to India ille, then if here come like Iran ille, Afghanistan ille, or any other countries, this one, so we are just avoiding to these things, releasing words in or training in our word embedding and word vector. We are generating vectors for subwords. I hope I'm explaining well this. Okay, so and also word embedding are generally trained for one language, or so they're not much ideal for code mix data. So what I did, I used training data, and using GenSim library, I trained word vector and also subword vector using that. So like that, again, I use the byte embedding tools and encoded all post stuff or comments into subwords, and then I generated a subword embedding. And as you know, also I, as I remember in first paper, first participant was talking about language model. Also, language model and ULM fit same. Word embedding are like a word representation. Language model are probability distribution. So actually, for language model, also we don't have a language model for code mix. As I understood, first team use language model, English language model, and trains their model and transfer knowledge of first language model for second one. But here, since I didn't find any subword embedding pre-trained, so I use a trained data set, trained corpus, and I generated a word embedding for my task. This is model construction part. As you can see, I trained word embedding using scheme for word vector schema we have of SIBO, but I use scheme. I prefer the scheme, and maybe because it is based on a word, it can predict a context of that word based on probability. Also, same way I generated subword embedding using training set and a combination of a word and char ingram. Word and char ingram, I use a contour vectorizer and give to MLP for training, and subword embedding I gave to BioLSM deep learning model. Actually, I'm not going to say what is a multi-navy bias, what is MLP and BioLSM, because all these are known. The known classifier and known model. What I did, just I combined all of them, and I choose. Maybe you are asking why you have chosen multinomial navy bias or MLP on this. I experimented many classifier, and based on which one was getting best result, I choose them and applied here for my hybrid model. And finally, predicted label, I use majority voting for final tag. So data set, yesterday also task organizer explained this, this is highly imbalanced. So it was very challenging to deal with it, and so many other statistics have been given by two previous team and also task organizer that I'm not going to explain again. And our result, MUCS, we obtained 0.62 F score for Tamil English and 0.68 for Malayalam. Also, if you want to compare our model with other teams, we can see we almost we didn't perform much well, but also we didn't do very badly. We were just in average. So in our future work, we are going to explore some more feature and applying like multi-channel deep learning model for BioLSM or neural network. Also, we can work about ULM fit and training in code mix data by collecting raw data from YouTube and creating a pre-trained language model and pre-trained word embedding that I think that can affect on our deep learning and transfer learning models. And this is our work, and if any question, I'm ready to answer.
Thanks for the presentations, Rahman.
Thank you.
So I will ask first question before the others ask. So you have
Yes.
count vectorized and then multinomial naive Bayes. You have also used count vectorized plus
Yes.
the the perceptron one. So, but the thing is, you are using word embedding before this. The context vectorization is to create the text into numbers. So, but the word embedding is doing that. So after the word embeddings, why are you using count vectorized methods? So that is my question. If you are, and you're doing the same with the word character engrams, again, this seems little bit of things. And but with the subword embeddings, that is which library you use to create subword embeddings, or you use your own subword embeddings?
I use a GenSim library for creating my subword embedding and skipgram subword embedding and word embedding. Actually, here as I use a similar configuration for this one and this one, if you see for MNB and MLP. So I use vectorizer and gave I converted, transform my vector to this type to that can be easily, that my machine learning classifier can be trained on those data. And here, yes, I use the GenSim similarly for BiLSCM. And
Okay.
here, for word and charangram, after extracting word and charangram from data, I use vectorizer and converted this count of charangram combination of both.
Okay. So there are no other questions. Before that, I have an announcement. So everybody who's going to present in this session, please share your slides through the Zoom link to IRLAB so that we can make this presentation easier. So next presentation, we are supposed to go for Sonic Mehta, but I didn't see any replies. So we are going to Arista Venkata Mandalam. And the paper is DITS 2020, Dravidian Code Mix Fire 2020, subword level sentiment analysis of Dravidian Code Mix data. So I give this, I'm unmuting Arista Venkata Mandalam, so she will be, I'm giving the floor to you.
1 minute.
Thank you.
Okay.
Now you start.
Okay. I've shared my PPT with the IR lab. Should I share my screen anyway, or?
You can share your screen. Yeah. If
Yes.
it is not working, then we will use your PPT.
Okay. Just give me a second. Right. Is my screen visible?
Yeah.
Yeah. Okay. Thank you. Hello, my name is Asrita Venkata Mandalam, and I will be presenting my team submission for the sentiment analysis of Dravidian code mix data track of FIRE 2020. My co-author is Dr. Yashwardhan Sharma, an associate professor, and we are from BITS Pilani, the Pilani campus. 1 second. Yeah, so this is just a short table of contents. And moving on to the problem description. So as mentioned in yesterday's track overview presentation, we've got a code mix data set of YouTube comments. The aim was to classify the given comment in the test data. So this is our data set. One moment. Yeah. So we've got 2 languages and we've got 5 different classes. So positive, negative, mixed feelings, an unknown state, and other languages. The other languages might include other Dravidian languages as well. It can include stuff like Hindi or French or English. In terms of related work, Dr. Chakravarti and his peers created the dataset. They've given an overview about the track and the process of creating the dataset as well. Bojanowski and his team at Facebook AI Research used character level n-grams in their skipgram model. The key points I took away from their paper was that they managed to cover out of vocabulary words and the fact that they didn't use any pre-processing but still outperformed baselines. An issue was that they did not work on code mix data, so I read the paper by Joshi and his team. They used a subword-based architecture as well, and the reason why I looked into this paper was because they had an imbalanced data set of code mix data also. So I think they had around 15% negative, 50% neutral, and 35% positive tweets or comments. The last paper I'd like to talk about is the one by Jose and team. So they surveyed publicly available code mix data sets, and they also took into account and represented statistics about the vocabulary size and sentence length of these data sets. So when it comes to pre-processing, one thing is that although Bojanowski's team did not do any pre-processing, I looked at the data and it seemed like it should be done. So we replaced all emojis with their meaning or sentiment, and we also replaced all Tamil and Malayalam characters with their English counterparts. This was done to ensure consistency across different versions of the same word. We, like the first team, we also converted our characters to lowercase, and this was done because it achieved an improvement in F1 score when it happened. And another reason why we did this was because sometimes people tend to mistype and they accidentally enter an uppercase character rather than a lowercase character when they're commenting or tweeting and so on. So after this, we obtained a set of characters from the data. The input to our model is this set of characters, and from that we created a one-dimensional convolution. We created a subword level representation through our one-dimensional convolution layer. So creating a subword level representation is important to make sure that different words that have the same root word or morpheme can be mapped together, such as these three words. We also used a max pooling layer to get to be able to get the most prominent features from the morpheme level feature map that was extracted before. After that, to get the connections between the features, we used 2 layers of LSTMs. And these are recurrent neural networks, and they were used so that they could process sequences and retain information. The reason why we used 2 different layers was to get a greater model complexity. And finally, we got the output of the model, and it was the comment that was inputted was classified. So we also used batch normalization to combat overfitting and early stopping to stop the training when the validation loss didn't improve after 4 epoch cycles. So these are our results, and we achieved a weighted average F1 score of 0.61 for the Tamil language and a weighted average score of 0.60 for the Malayalam language. The reason why the F1 score for the Tamil language is lower than the precision and the recall is because it's the weighted average and it's taken from the 5 classes rather than the combination of the scores from the precision and the recall. So overall, we achieved a rank of 5 and 12 for the Tamil and Malayalam tasks respectively. Yeah, so this is my error analysis. Over here, we can see 2 different graphs of the misclassified comments according to language. The x-axis represents the class, and the colorful bars represent what these misclassified comments were classified into. So I forgot to mention before, our unknown state has a high precision and a low recall for the Tamil language, and as a result has a low F1 score. This was due to the high false negative rate for the unknown class. We can see that the non-Tamil class also did well after the positive class receiving the highest F1 score, the non-Tamil class received the next highest F1 score. And this was due to the different set of words and the different vocabulary. Any misclassified words were classified as mostly positive due to words that it had in common with those classes, such as actor names like Rajnikant or Talaiva. So we can say the same for the rest of the classes also. And we noticed that the mixed feelings class for both of the data sets received classification of positive or negative. And this is because most of them have positive words, but may end with a couple of negative words, or they have positive words and have a negative connotation, and so on. So for the Malayalam dataset, even though it was more balanced, we noticed that the non-Malayalam class did perform pretty well. And anything that was not written in the same script as the Malayalam script was classified correctly as out of Malayalam. And it did have some trouble when names of actors were used along with English words, as this is usually seen in positive comments. So from our conclusion, we can conclude that subwords did prove to be useful in code mix languages to account for variations in spellings. And our positive comments class received the highest score. This is mainly due to two reasons: the skewed class distribution and the change in vocabulary usage. So when someone is praising an actor or a movie trailer, they tend to use different words, and these words generally don't appear in the other classes unless it's followed, preceded by a not, or it can also be seen in the mixed feelings class. So our third conclusion was that the non-Tamil and non-Malayalam comments received the next highest score, and this is due to the different vocabulary as it is not from those languages. For future work, we aim to add a sarcasm detection feature, as many comments online are usually sarcastic. They use positive words and positive emojis, but they usually have a negative connotation associated with them. And this is usually done when people are mocking the topic of discussion or a feature that is appearing in the video. So this is just a few references, and I'd like to thank the organizers and the student volunteers. I enjoyed participating in the track, and I hope to improve upon my contribution towards this field. Thank you.
Thanks for the nice presentation, Arista. So it was really nice work. So you have used different subwords and things. This is an interesting study. So my question was going back to the results. So in Tamil and Malayalam, the next slide.
Okay.
So here you see in the unknown state in Malayalam, you see there is like, it's all in all the classes are coming.
Yeah, that is true. So I'm not really sure how to combat that yet, but I'm guessing it's because the vocabulary usage for the unknown state was pretty, it was common with the mixed feelings state as well. And the positive distribution can be discluded because we knew that it was, the data set was kind of skewed in that favor. So that was expected.
Okay. So in Tamil, this is becoming most of the classes are, I think, predicted as positive because of the data distribution, I believe. So,
but it is a representation of real life data.
Okay.
Yeah.
Okay. Nice presentations.
Thank you.
Thanks.
Any other questions? Okay. Thank you.
Okay. So now all the presentation, Sonic has presented it, right? No, no, I think next one is the Sonic Mehta, Sainik Kumar Mehta. So that is by, the title is JUNLP, Dravidian Code Mix, Sentiment Classification of Code Mix Suite using Bidirectional RNN and Language Tags. So, yeah.
Okay, can you hear me?
Yes. Can you share your screen?
Just a second. Okay, so is it visible, the PPT?
Yes.
Okay, so this is Sainik Kumar Mahata. Good evening, everyone. I will be presenting the description of a system that was submitted to the sentiment analysis of Dravidian code mixed languages shared task at FIRE 2020. So for the introductory comments, so as we all know, sentiment analysis is a process of using natural language processing, text analysis, and statistics to classify a written text based on its sentiment, be it either positive, negative, or neutral. So sentiment analysis has been an active area of NLP research in the past 2 decades. While sentiment analysis is very much mature for English language, very less work has been done for Dravidian language family. As well as Dravidian languages are generally considered low resourced. Also, with the advent of social media, there is an increase in demand of of sentiment analysis of social media texts. Uh, as far as for the Indian subcontinent, social media texts normally are not in one language, and they are generally code mixed in nature. This is because India has a linguistically diverse diaspora, and a large number of Indian people are very comfortable using more than one languages to communicate. So traditional sentiment analysis models don't work properly for code mixed texts, and hence to try and solve this problem, we participated in the task of English and Dravidian code mixed sentiment analysis at the message level. So for the data, the organizers provided us with two data. So one is for the Tamil English code mixed data, and the second one is the Malayalam English code mixed data. And both of them were derived from YouTube video comments. And there were three types of code mixed sentences. It contained intersentential switch, intrasentential switch, and tag switching. And the sentences that were given to us were tagged using 5 output labels: positive, negative, mixed feelings, not Tamil, and unknown state. But we participated only in the sentiment analysis of English Tamil code mixed texts and not for the English Malayalam. And obviously, the organizers provided us with the training data as well as the validation data. Now, for the framework, first and foremost, we pre-processed the training data. So, like the first step was extra tokens like mentions, punctuations, URLs, extra white spaces, and hashtags were removed. Secondly, the sentences were tokenized using the NLTK library. Thirdly, the tokenized words were used, or the tokenized corpus was used to train the fast text embedding. And after training, we were able to generate word vectors of size 100. And obviously, skip-gram model was used for this because skip-gram model works well with small amount of training data, and it is able to represent rare words or phrases. And lastly, we used an extra feature called like language tag, in which every word was tagged with either English or non-English. And for this tagging, we use the NLTK corpus. And lastly, as we saw in the previous slides as well, the data was imbalanced. Generally, positive, negative comments were higher, and the other levels were lower. So what we did was we handled this class imbalance using the class weight parameter of the sklearn package. So for the model, we had 4 models. So first we had LSTMs with language tags. Second, we have had LSTMs without language tags. Then we tried using bidirectional LSTMs with language tags, as well as bidirectional LSTMs without language tags. Now, why did we use bidirectional LSTMs? Because generally, whenever we use bidirectional LSTMs, it runs our inputs in 2 ways: one from the past to the future, and one from the future to the past. And obviously, it has been shown that bi-LSTMs show very good results, as they can understand the context of the sentence better. Now, these were some of the parameters. Before going into the parameters, I would like to go to the model first. So as we can see, we have a sentence, we have the words of the sentence. So every word was checked from the NLTK corpus to find out whether it is English or non-English. And after finding it out, they were passed. They were marked. They were marked using unique integers, and they were passed to the embedding layer. Now also the words were converted to one-hot vectors, and it was searched in the embedding uh, that was generated using the fast text embedding. So after searching, whenever the word matched, the specific word vector of that word, a 100-dimensional word vector of that word, was extracted, and again through the embedding layer were merged together with the help of the concatenate layer. So for the LSTM models, this was LSTM models. So we used two hidden layers, and for the bidirectional LSTM models, we used two layers of bidirectional LSTM layers as well. So after that, the outputs of the LSTM layers were passed to a dense layer, and then they were mapped with the output labels. So for the hidden parameters, as we discussed earlier, we had two hidden layers. Batch size was kept at 32. There were 50 epochs. Optimizer was set as Adam. Loss was sparse categorical cross entropy, and the validation speed was given as 0.1. And early stopping was used to stop the overfitting. Now, for the models that we trained, it was validated using the data provided by the organizers. So after the validation, our four models gave these results. So for accuracy, F1 score, precision, and recall, these were the results. So as we can see that the model with that was trained using bidirectional LSTMs with language tags had the better F1 score. So this model was selected for submission, and it was deployed on the test data consisting of 3149 English Tamil code mix sentences given by the organizers. So when those organizers scored the systems, scored our system, the precision came at 0.59, recall came at 0.66, and F1 score came at 0.58. So to conclude, so in this work, we attempted to solve the problem of sentiment analysis of code mixed English Tamil data. Our system was based on bidirectional LSTMs along with language tag features. Also, fast text embedding was used to generate word vectors to train the model, and our model garnered F1 score of 0.58 when tested by the organizers. For the future work, we would like to continue this and increase the size of the data. We would also like to, so in this case, we used fast text. So we would like to use the state-of-the-art embeddings like BERT, Roberta, etc. Since it is code mixed data, so we would like to also incorporate the concept of matrix and embedded languages, and we can also use other NLP features like senti-wordnet, etc. So that was it. Thank you.
Thanks. It was a nice presentation. If anybody has any question? I don't see any questions.
Okay.
Thanks.
Okay. So
I'm changing giving the chair session to Vignesh and Ruba, so they will be chairing the sessions.
So I can stop the share, right?
Yeah, you can
okay.
stop sharing the screen. Yeah. So we haven't seen the Hare Krishna, so that is the last author. So we are waiting for him. We couldn't get it. So probably we shall take 10 minutes break and then continue with the sessions. And then by the next half will be chaired by Vignesh and Ruba and then Shardul. So the presenters, please share your PPTs in the Zoom chat. The presenters are Shubhankar. The next sessions will be Shubhankar, Balasutaram, and Abhinav Kumar, Nikita Kanwar, Supriya Chanda, Parameshwari Krishnamurthy, and Sauman Dolgar, and Yandravatti Prakash Babu. So please share your PPTs in the and Judith Jeffria, you have not yet shared this PPT. Can you please share this? And we are taking 10 minutes break. After that, Vignesh and Ruba will chair the sessions. So we will meet in 10 minutes.
Okay.
Hello, Vignesh.
Oh,
Yeah, you can start the session.
yeah. Hello. Hi, everyone. I think the next presentation will be from Shubhankar Banerjee. Hello. Hi. If you're ready with your presentation, could you please share it with everyone?
Yeah, hi. Am I audible?
Yes.
Okay.
Yeah.
Should I share my screen?
Yes, please.
Okay. Can you see the screen? Is it visible?
No. No, it's not.
Okay. Is it visible now?
I don't see that yet.
Okay.
Can others? Yeah. Yes. Now.
Is it there?
Perfect.
Yeah.
Yes.
Yeah. Okay. So hello everyone. I'll be presenting my research paper. Basically, the task of the task and the shared task was about sentiment analysis of code mixed data, code mixed Dravidian text, and I used ExcelNet to perform this task, and I'll be discussing the methods I employed as well as the results I got, and the analysis of like what all I got correct and incorrect. So basically, like everyone before me has been discussing, this that shared task. This shared task was primarily about sentiment analysis, and like all of my peers have previously told, sentiment analysis is essentially an analysis of textual data, and like according to Wikipedia, it's not necessarily textual data. It can be other sorts of data as well, but we should be sticking to textual data specifically for the premise of this particular shared task. And coming back to the point that I was trying to make, sentiment analysis is essentially the analysis of textual data to figure out useful opinions and trends from that. Now, why is it useful? So let's say a country is going to hold general elections, and there are exit polls happening all over the news channels and all of that. So how do we figure out like what is the mood of the general public? So in those scenarios, sentiment analysis can prove to be a very useful useful tool, because there is so much data out there on social media texts, and if we can effectively utilize that data, effectively analyze that data, then it can provide us useful insights to such things. Also, it can be used by organizations for making important marketing decisions. And so the premise of this task is to perform sentiment analysis. Now, the data that we've been provided involves code mix data. So what essentially is code mixing is basically when people, while communicating, while conversating, while writing, tend to mix different languages together. Now, when they specifically, now there are the different types of code mixing, different types of amalgamation of languages. I mean, code switching, borrowing, and all of that. When they tend to do this in an intrasentential way, this is specifically called code mixing. So I've given an example of code mix. Pardon this typo in here. This is essentially English Tamil code mix data. So Vanakkam is a Tamil greeting, and which is followed by how is everyone at home. So this is a very common way of greeting people, like very polite and common way of greeting people in certain parts of our country. So that's code mixing in here. Now, in this particular shared task, we've been provided with code mix Tamil as well as code mix Malayalam data, and we had to effectively analyze that data and provide useful insights from that data. Now, like I previously said, the objective was this. Now, coming back to the data set. The data set that we've been provided has been collected by by Dr. Chakravarti and his peers. It was basically scraped up from YouTube comments. It is basically these data sets are primarily social media comments, and they have been scraped off from the internet, from YouTube comments. And so this data sets, like I previously mentioned, sentiment analysis can be used in certain scenarios. The example which I gave, sentiment analysis can be effectively used to draw sentiments of the general public during general elections. That application can be applied to this particular, can be understood in the context of this particular shared task data, this particular data, because we are trying to model the social media data. So that's a very important source of information, especially in a country like India, which has a huge user base of social media platforms. So that's effectively. And these are, I would not go into the details of what the data set is. The data set has 15,744 sentences of Tamil English, and I've used the acronym for that, Tanglish, and 6,738 sentences from Malayalam English texts. So that's essentially the size of the data sets. And like there were different, there are these data sets are primarily written in the Latin script, the Roman Latin script, and they are effectively code mixed. The model, now I would try to like explain the model that we used. The model that we effectively used was the XLNet model. The XLNet is a transformer architecture. These transformer architectures, they basically trace back their origins to the BERT architecture. Now, XLNet is a bit different from the traditional transformer architectures that are out there. It is different because it employs a different sort of a language modeling technique to model model the languages. Generally, the technique that is employed by other language models is primarily masked language modeling, or commonly known as MLM. Whereas XLNet goes on to employ a technique which is in common lingua known as autoregressive language modeling. Now, how is autoregressive language modeling different than masked language modeling? It is different because it essentially takes in sequences of sentences and tries to predict the next sequence, next word in a particular, or next token in a particular sequence. So that's how it is different. Whereas in masked language modeling, we effectively take in bidirectional context into place. It's not limited to just predicting the word in a particular sequence, but taking into account all the neighbors of a given token, of a hidden token on board in both the directions, and making a prediction on the basis of that. Whereas autoregressive language modeling is more or less one-dimensional, and it is more suited to the task of language modeling. Why? Because essentially the empirical definition of language modeling tells us that it is more or less predicting the next word in a token. Now, we had selected this particular model in here because we believe that this is a better way of modeling languages, and this can be used to tackle this task in a better possible manner. Now, another very good thing about language, another reason for which we used this particular model in this particular scenario was the fact that this model uses permutation language modeling. So permutation language modeling is essentially mixing up of the sequence. You basically try to predict the next word in a given sequence by permutating all the words before it in all possible different combinations, and this gives you a better ability to learn different contexts. And in case of social media data, where there is a lot of noise in there, this can prove to be very useful, because you can try to learn different variations of the input sequence. So that's why these are the two primary reasons that we used XLNet model for. As far as the feeding the model was concerned, the data, this model takes in, we had used the implementation that was provided by the Hugging Face library. Hugging Face, it was provided by the K-Train library, which was a wrapper for the implementation provided by the Hugging Face library. And this particular wrapper takes in the input sentences as it is. We did not perform any such pre-processing except for normal cleaning of the data, such as lower casing of all the English sentences and normal tokenization. We used adaptive annealing techniques, learning rates for the purpose of learning, helping this model fine-tune on the given data. Also, this model was pre-trained on, the model that we chose was pre-trained on multilingual data, on multilingual Indian data, on a multilingual Indian data set, and that's the model that we chose for our problem. And then subsequently, post training, we tried to test our model on the given test data sets that were provided by the organizers. The results, now I would like to discuss the results that we observed. The thing that we primarily observed with the results was that this model performs not so very well in the case of Tamil English, but performs very well in the case of Malayalam English. And the reason for that was, when we basically read about the description of the model that we had used, XLNet, the pre-training that had been done, it had been trained on a very large Malayalam corpus as compared to a smaller corpus of Tamil. So if you look at the accuracy metric, the Malayalam has a better accuracy as compared to the Tamil accuracy for the Tamil. So this basically predicted the fact that it basically insinuated the fact that there is a substantial language drift, a substantial drift of language during the consideration of Tamil English data set, and also the fact that such models are very prone to language drifts. These models are and this can subsequently impede the performance of these models. Also, another problem with the Tamil English dataset was that during the analysis of the dataset, we found that different words, there were same words had different spellings, and this led to a potential disagreement in the sentiment. For example, there were multiple spellings for the word vanakkam in there, and hence essentially that the fact that it expresses a positive sentiment wasn't effectively captured because there was a variation in spelling. And which brings us to our future work, on which we are working right now, which takes us to the fact that these models, they need to be retrained on a larger amount of data, larger corpuses, so that they can be effectively used to model on downstream tasks such as sentiment analysis. It would be even better if they could be pre-trained on code mix data, and that is something that we are trying to do. And also a possible line of future work could be basically incorporation of some sort of spelling correction techniques or clustering based spelling correction techniques into these models, which could effectively make them more robust to variations in the spellings. And that would yeah, that's all I had to say. Thank you so much for giving me this opportunity.
Thank you, Shubhankar. That was a good presentation. I had a few questions when you described about this model. Yeah. You have trained it on you've used the pre-trained models, but finally you said that they were not trained on code mixed data. But do you think that some of those the model could be? Did you use any features of code mixed data to improve that, or you just used the pre-trained model?
No, we just used the pre-trained models that were available with the Hugging Face library. That was primarily because of the limitation of compute that we had. So we couldn't actually incorporate any sort of pre-training. We improve on the pre-training. We just used on the pre-training the pre-trained models that were already available. However, we did the cleaning on the data that we had while during the fine-tuning task, and that essentially is the bottleneck with language models, as we know.
Okay. But do you think that some of those in pre-processing step, say using emoji information or something, do you think that can improve the results, or did you try anything like that? Were there any experiments?
I don't think that XLNet is capable enough to handle emojis, but yes, a possible line of work could be basically replacing emojis by certain words. That is also something that we had considered. For example, if there is an emoji that's a smiley, so replacing that with some sort of a variant of a Tamil English or a Malayalam English word with that. So, and then training the model, fine-tuning the model on that. That's something that could be done. Yes.
Okay, fine. Is there any other question from other participants or hosts? You can put your questions on the chat box. Yeah. I think that's it. Okay, thank you very much for your presentation. Thanks.
Can I stop sharing my screen?
Yeah, yes, please. Thanks.
Thank you.
The next paper would be from Balasundar Raman. Could you please share your screen?
Yeah, let me share. Is my screen visible?
Yes, I can see it.
Thanks, Dinesh. Hello, everyone. Thank you for the organizers to share this data set and providing us with this opportunity. So let me describe our system, Thidum Nandom, which we developed to classify sentiment polarity on the given data set. Let me proceed. I don't have to describe a lot of the data set itself. In yesterday's session, Bharti Raja provided good overview. But I just call out the main features or characteristics of the data set we focused on in solving this problem. Essentially, we observed the code mixing, of course, and the fact that most of the comments had been written in the Roman alphabet. And we also noticed that there was a liberal use of emoji there. And especially in the Malayalam dataset, we noticed some amount of sarcasm, which of course is a very difficult thing to catch based on pure text features. And then, so the main features we depended on to kind of capture these characteristics were emojis themselves as such, and then the sentiment inferred from the emoji. I will go into that during the features discussion. And then we also used sound decks on the words themselves to capture spelling variation. I mean, to the extent we looked at the related literature, this kind of use on code mixed and script mixed data for this kind of an application seems to be kind of novel. Some of the peer reviewers had also highlighted that. So we essentially built two classifiers, one which was based on an SGD, it was a linear classifier, and another which was an LSTM based classifier. I'll discuss each of these briefly. In terms of performance, we put the highest performing classifier, which we did get implemented after the task deadline while working on the peer reviewers' feedback, and I'll go into that in a little while. So in terms of method, we realized that pre-processing is very important for this kind of a data set, given the spelling variation and so on, and even the choice of features compared to even the we need to choose. So one of the things we did was to transliterate the Roman spelling into Tamil and Malayalam using a brute force approach. We used a library called IndicTrans, and then of course that won't solve it because it's a very literal kind of transliteration. But we used language-specific sound decks to get a canonical representation for the various different spellings. I'll give some examples later. Then we also did this other thing. Basically, we took the emojis, separated them out as a feature, as well as attached a sentiment for each emoji. I'll again go into the details later. And then followed by a regular bag of words and TF-IDF vectorizer on that to generate the vector. And we also used n-grams up to, word n-grams up to 4 grams. And like I mentioned earlier, for the competition itself, we had used an SGD and an LSTM. We used grid search to kind of tune the hyperparameters as well as the weights of the different features. I'll mention that briefly in the classifier section. So yeah, like I mentioned, what we did was we extracted the emoji which was inline in the comments, and then used Sentimoji to assign a sentiment score just for the emoji individually. And we did notice that there were a number of new emoji which were not captured by Sentimoji itself. So what we did was we learned the sentiment by running it on the training data itself, disregarding the text and then just using the emoji and then the sentiment associated in the training data. We then assigned that as a dictionary. That seemed to have helped. This is especially useful in case of sarcasm, I mean, because it's kind of extra verbal, so to say. So that's one thing we found helpful. The other, I have given an example here. I mean, often in colloquial use, the word arumai could be said as Aruma in Tamil, and there is some amount of elision in the vowel as well. And this is just one kind of variation, but this variation gets amplified when you have when you write it in Roman alphabet, where you can write it in probably 4 or 5 other ways. What we found was we first tried a regular soundex, obviously that's built for Roman alphabet, and you would get something like A65 from this in Roman alphabet. However, when we transliterate and do a soundex which is language specific, there is a soundex for Indian languages developed and open sourced by Swatantra Computing, I guess. We got like a really good accuracy in terms of mapping multiple spellings to the same value. And then we also used inferred language from Google API as one of the features. And word vector is a regular feature, and document length range also seem to predict some amount, at least for some commands. So we kind of use some buckets of ranges, and these were the main features. The two classifiers were kind of straightforward for a linear model. Modified Huber laws, and learning rate was 0.0001, and feature weights were learned using grid search. What we found interesting was that the weights were somewhat different between Malayalam and Tamil. So that's something where the grid search was useful for us, and probably that kind of characterizes the data also somewhat. And as for the LSTM, we used a 4-layered LSTM embedding. We didn't use any pre-trained embedding because we couldn't find one which had like Roman or code mix text itself. But I guess there are other possibilities where we could use a pre-trained embedding and kind of transfer using the current training data. But however, we didn't venture that much. Because of that, the deep learning model gave us less accuracy at less of a weighted F1 score. And these are the results from these two classifiers, SGDA and LSTM, on the validation set as well as the test set. As you can see, the scores are reasonable, and we were ranked the 4th in the Tamil stream, and then 9th in Malayalam, and the margin was fairly small in the Tamil data set. However, during the paper peer review, many reviewers had asked for repeating some experiments to let us know whether SGD was the highest performing linear classifier. While we ran the experiments, we realized that when we did the benchmarking, we had not used the more recent set of features, and hence SGD had won. But later, when we repeated the experiments, logistic regression gave a very good result. And as you can see, the scores are really high. I would at least it is definitely better than any other score during the contest. I don't know if other improvements were done later by other teams as well. I mean, regardless, I think this shows that even a linear model can work really well with the right set of features, and especially for this kind of a data set where the size of data set is small, there is a significant class imbalance, and then there is a lot of dilution in terms of variation in spelling and so on. So that's one major learning for us. To conclude, we have logistic regression performed the best in our case, and we believe this use of soundex to harmonize spelling variants could be widely used in such kind of data sets where there is a lot of spelling variation. We also explored another possibility where we tried a SimSpell based spell correction However, because of performance reasons, it is a very memory-intensive kind of implementation, and that we couldn't go beyond edit distance 2 for an agglutinative language for both Tamil and Malayalam. With edit distance 2, we can't hope to get correct dictionary matches. So we are now exploring combining edit distance with Soundex to get better results. That's future work. Yeah, that's more or less the summary. Thank you to the organizers. I think Bharatiraja had taken a lot of effort in kind of guiding us through the paper review process as well, in getting our paper issues fixed and so on, as well as the entire team gave us timely information, and the data set itself is so valuable. Thanks to a couple of others, friends who we have acknowledged in the paper as well, who have helped us through this effort. Yeah, that's all from my side. I'll be happy to answer any questions.
Thank you very much. Thank you very much for the presentation. I think it was a very good, interesting idea to focus on feature generation and working on that. It was very good.
Thank you.
Yeah, I had a couple of questions regarding the Soundex. I didn't understand that very correctly.
Sure.
Suppose you had morphological variants, not just the sound variants. You had Arumai and Aruma. You gave an example. But you had other morphological variants. I can't think anything right now. But,
I see what you mean. So let's say we have different case markers, right? Arumaya and Arumaya.
And the spoken form could be different. So do you think this approach would be useful in that scenario?
That's a very good question, Vignesh. So in an ideal world, I would say I would first do the spell-based spell correction and then try to do some amount of lemmatization or some kind of morphological analysis, but we're still not as evolved on that. However, with Soundex, we do achieve some amount of kind of normalization. Because what happens is Soundex takes the first alphabet as such, and then while it computes the hash value, it kind of ignores the last suffix based on the length of the word. So because of that, typically it's Tamil being an suffixal language when it comes to case markers, etc. These variants will have the same Soundex value. So that way we will still get it, but we might occasionally miss out if the variation happens in like midway in the word. Yeah, but at least it will be better than not doing Soundex.
Right. Thanks for that. And
just
one more question I had. Sorry.
No problem.
In the word vector, you have used some n-grams as well, word n-grams.
Yes. Yes.
So what advantage does it have? Can you please?
Yeah, sure. So what happens is, especially in the sentiment context, right? The sentiment determination happens beyond the word. So there could be negation involved and so on. So if somebody says, Parama odade odadu. So just the last word negates whatever else which preceded that. So suppose, I mean, it can get complex if there is more than one negation word.
Okay.
So yeah, exactly.
Sorry, I got it. Okay.
Yeah,
it's the usual one. Okay.
Yeah, it's the usual one.
Okay, thanks. Is there any other question from others? Yeah. I think we are done. Okay, thank you very much.
Thank you. Thanks, everyone. Yeah.
Thanks. Bye.
Bye.
The next participant is Abhinav Kumar. Can you raise your hand? I can see two people. Abhinav Kumar. Yeah. Hello. If you can share your screen, the next participant.
Yeah, hello. Yeah, am I audible?
Yes.
Yeah, okay, fine. I'm just sharing my screen.
Wait for 1 minute.
Okay. Which Abhinav Kumar is it? May I know?
Vinap Kumar from NIT Patna. Actually,
no. Yeah, could you please raise your hand in this? There is an option.
Yeah, Vignesh, he is co-host now.
Yeah, right.
Shall I share the screen
now? Yes.
Okay, fine. Hopefully my screen is visible.
Yeah.
Yeah, actually, this is Sunil Soumya. Actually, Abhinav is not present. So on behalf of him, I'm presenting the paper. I'm the co-author of this paper.
Yeah. Yes.
Yeah. Okay. So good evening to all. So I will be presenting the paper Hybrid CNN and BiLSTM Network for Sentiment Analysis of Dravidian Code Mix Social Media Posts. Okay. Second. So these are the outlines. I'll be going through these: introduction, then methodology, results part, conclusion, and finally the references which I have used in the paper. Okay, so starting with the introduction, here I want to just point out why the sentiment analysis is one of the important tasks in the natural language processing. And for that one, I have listed some of the applications, like in the e-commerce, for example. Suppose someone wants to buy a product. So if that user wants to see how the quality of the product is, so he can judge that one based on the cumulative ratings which is given by the rest of the community. So what their sentiment is toward the quality of the product, and then based on that one can decide whether he or she wants to buy that product or not. That is one of the application in e-commerce. Spam detection, again, this sentiment analysis is very helpful. That again, I'll take the example of the e-commerce reviews, that if someone has written a reviews and that review is the fake reviews or a spam review. So if the people are commenting about that review, that if suppose that review is saying that product quality is good, but in actually the community is saying that no, product quality is not good. So on just counterpart of that review, different people comments that no, whatever you are writing, that is not correct and all. So if we are extracting the sentiment, then we can easily say that that particular review is a spam or not spam. That could be one of the feature. Right. So again, that there the sentiment analysis will play a very important role. Recommendation system, as all of we know, that the sentiment plays a very important role, and based on the sentiment, based on the how you have purchase, suppose the product or any services, and how the other people have purchased any product or services, you will be offered the next one. Right. So suppose you have gone through one product and the other community are going to the next one. So sentiment, based on the sentiment, again, you will get the same kind of recommendation. Similarly, in the social media monitoring also, it plays a very essential role. Again, I'll take the example of the business only, just for the advertisement of the product. The company do see how the people are responding about the quality of a particular product or any services, and based on that one, then they can improve their quality or something. If you take the example of the YouTube, if I have created my channel posting some videos, and then I'm just observing that how the other people are reacting on the videos which I have posted, what they are saying. Should I increase? Should I improve the quality, or whatever they are suggesting? Based on that one, again, we can add the more quality. We can improve the quality of the video. So these are some of the areas where the sentiment analysis, and there are many others where the sentiment analysis plays a very important role in NLP. So in this particular task, I'll just speak first about this. So data, so basically the code mix data was given in the Malayalam with English and the Tamil with English, and the task was like we have to classify the data in the given classes, whether it is positive, mixed feeling, negative, positive, not Malayalam or not Tamil. In the case of Tamil, code mixed, unknown state, and like that. So this is the data statistics which have been given. So the task is very known to us. And this is the data statistic. As we can see that, I'll just point out one thing here, that the number of data points in the case of suppose mixed filling or the negative or the positive, you can see that there is a variations. For example, in the positive, we have more than 2000 data, but in the case of mixed filling, we have only 200 and near to 300 data. Right. So these are, we can see that there is a large variation among some of the classes. Similarly, here also we can see that for North Tamil, we have very less data as compared to the other classes. So that has some impact when we trained our model and we tested on the validation data, right? Okay, so that was the part about the task and the data statistics. And to classify of this classification task, we have used two different approaches. Right, and in both approaches, we have used the hybrid model. Hybrid model in the sense that we use two different model in parallel. Okay, the data set was same, that the YouTube post which was been given, and we extracted the features from both these model. Okay, in the for example, here you can see that for the post which has been given. Okay, from there we extracted the word embedding. So we fixed the maximum word length of every post as 30, represented every word into 100 dimension of vector, and then from there we created the sentence representation, or you can say, yeah, of that particular post. We extracted the features of the two layered of CNN. Whatever feature we got, we flattened that one into 512 one-dimensional of features. And then again, in the parallel, we have also extracted the character embedding from the same post. Right, and we found that in the data set, there are 70 unique characters. And for every character, we represented, for every post exactly, we took 200 characters, and every characters was represented in 70 dimensional vector. Again, we created one that's representation, matrix representation out of this one, extracted the feature from the same two-layered CNN, then the flattened layer, and then we concatenated whatever features we extracted from this model and this model, concatenated together here in the concatenated layer, passed to the dense layer, and finally we classified into this 5 classes of data. So that was that's how we designed the network. In the second model, we changed a little bit, that in this case, for the character embedding, we use the character embedding for this CNN part. Right, here also we kept it same, but for the word embedding, now we are giving this word embedding as an input to the stacked by LSTM layer. Okay, that's the change. So we were just checking with different models, right? And we also trained this hybrid model. We extracted the feature from this LSTM model and this CNN model, concatenated, and then we did the classification. And so these two models we tried. And yeah, before that one, we did some data pre-processing. That in the data pre-processing, we removed multiple spaces which was coming between the words. So we reduced it to one space only if there was more than one space between the words. We also replaced the ampersand sign at the rate symbols to their English word as and at respectively. We replaced the numeric values like 1, 2, 3 to its corresponding English words as 1, 2, like it is written here, and so on. So these are the data processing steps we performed. And I just said that how we created the character embedding and word embedding, that we fixed the 200 characters for each post. Suppose there was more than 200 character in any post, we took the first 100 character only. Okay, so there was a chance that the characters which we were taking from each post to there was a chance that it was repeating. Okay, why? Because we had only 70 unique characters throughout the document. So, but we kept it as it is just to maintain the sequence also. And we, for every character, we took the 70 dimensional vector, right? And that's how we created the character embedding. So for word embedding, as I said, for every post, we fixed the 30 words and we represented every word in the 100 dimensional vector. This is the other hyperparameter which we tuned during the training of the model. So we number of CNN layer was 2 and 2 in the case of the CNN and CNN hybrid model. And number of bilastm we did not use in this case, so it was empty. Batch size was 32. Epoch, we checked with various epoch, and at last we got the best performance at 200, so we fixed it at 200. Loss categorical cross entropy optimizer was Adam. Activation function, relu and softmax we used at the output layer. Dropout and pooling window was 5. Similarly, for this hybrid, other hybrid model, CNN plus bilastm, the number of CNN layer for the character embedding was 2. The bilastm, again, we use the 2 bilastm layer stacked on top of each other. Then batch size was 32, epoch was 200, and other parameters was almost same as we used in the first case. This was the result, what we got for different classes. And as you can see that as it was given, the direction was given by the task that we have to calculate the weighted average. And this is the weighted average what we got. In the case of the Malayalam code mix data, 0.69. In the case of the CNN plus CNN hybrid model, and the best this and the other one here, you can see that for the weighted average in the case of CNN plus bilastm, it was just 69, and in the case of F1 score was just 0.68 in the case of CNN plus bilastm. So we submitted this one. In the case of Tamil and code mixed, we got the best weighted average for this CNN plus bilastm hybrid model, where the F1 score, which we reported, was 0.61. The other results what we got, like confusion matrix, as you can see that the lowest we got for the mixed failing, which was 0.41, and the highest which we got for the 0.82. 0.82, right? So it means that the 82 data out of 100, if we suppose it was correctly predicted by the system, by the model what we have. And the same, the representation of this one is the ROC curve for the Malayalam and code mix data for the same CNN plus CNN hybrid model. Similarly, for the Tamil code mix data, this was the confusion matrix, where again for the positive class, the prediction was highest, 0.85. The most of the data in this class was correctly identified as compared to the other classes, and this is the ROC curve. And this was our task. So this is the conclusion. So sentiment analysis of the textual contents has significant uses in the various natural language processing tasks. We first identified why it is with some of the examples. And then we proposed 2 different hybrid model, first with CNN and CNN in parallel, extracted the features from both, concatenated, and then did the classification. And in the second case, CNN with bilastm, and then got our classification result though. So we found that the CNN plus CNN was good for Malayalam code mix data, and the CNN plus bilastm hybrid model performed best for the Tamil code mix data. And these are some of the references which we used in our text. Paper. Thank you so much. That's all from my side.
Thank you. Thank you very much for the presentation. I had one question. You mentioned about this pre-processing step. I noticed that it seems that you're using all the characters as well as the words. Did you not consider removing the most frequent ones, like which will not contribute to the sentiments, like very common function words? Did you do
maybe you're
like
talking about the stop words.
Stop words, yeah.
Actually, we did not remove it, but we have tried it, but it was it did not have much impact on. Once we removed it, it did not have the much impact on the overall accuracy what we were getting.
Okay, fine. I thought like maybe if you had too many characters repeating, maybe it will skew it. Okay, that's one question I had. Another one is the class confusion that you showed in Tamil data seems to be more than in Malayalam. Is there any analysis that you performed on this conclusion?
This confusion matrix you're talking about?
Yeah. You go to the Tamil code mix confusion matrix. Yeah.
This one.
Yeah. Here, it seems to be the class confusion is more compared to the Malayalam one. Is there anything about the data which explains this, or do you notice something?
we did not focused on why it was like that, right?
Okay.
Right now. So we got this and we submitted, but I guess that because there was some in the class imbalance, although we uses the weighted average F1 score, but still this was the case. We have to consider it. We should realize it, and that maybe that will help to improve the accuracy.
Yeah, because it will help understanding what's
Yes,
the
yes.
problem, right? Okay.
Yes.
All right. And one more question from another person, like what library did you use for implementing the CNN character and BILSTM? Which one did you use, Keras or TensorFlow?
Keras. We have
Okay.
used Keras, yes.
All right. Thank you.
Yeah.
Is there any other question from anybody else? Okay. If there is no question from anybody, may I ask you to share this presentation to IRLAB, one of the IRLAB DAICT? Can you share it with him?
Oh, yeah. Ask IRLAB
LAB.
DICT.
Yes. Can you
And then
share the
more. I have to
presentation?
go to the more, right?
Hello.
Yeah.
I will
Please.
take care of it later on.
I'll stop sharing, right?
Yeah.
All right.
Okay.
Okay. Thank you very much. Thanks.
Thank you so much.
The next session will be chaired by Shardul and Navya.
Yeah, thanks, Vignesh.
Thank you.
Yeah. Before moving on to the papers from this session, there was one missing presentation by Hari Krishnan. I think, Hari, if you're ready, you may proceed.
So, can I hear? Are you hearing me?
Yeah, loud and clear.
So, can I share my screen, sir?
Yeah, go ahead.
Sorry, sir. Some technical delays and my lab is
That's
not.
fine. That's fine.
So it's my screen is visible.
Yeah.
So shall I continue, sir?
Yep.
So, hello, sir. Good evening. I'm Hari Krishnan. I'm from Anna University, Trichy, and my other team members are Radha Krishnan, and my mentor is Sridhar Swaminathan, sir. And my title is Social Media Sentimental Analysis for Dravidian Languages Using Machine Learning and Deep Learning and Ensemble Approaches. So first about sentiment analysis is mainly used for identifying, classifying the type of the comment or text in the social media, in the internet or social media thing. So that's competition is for this competition is a sentimental analysis of code mix data. That means mixing of Tamil and English or Malayalam and English languages. So from let's start my work. So I'm from Tamil Nadu, so I'm choosing Tamil English task only. So part of this challenge, I submit. We will do. So we done state of the art machine learning algorithms and deep learning models, and also perform doing one ensemble model for the voting max voting classifier for the code mixed data. Such machine learning models are used by as naive Bayes, decision tree, random forest, and AdaBoost with the decision tree. And the deep learning model is long short-term memory LSTM. And at last we developed ensemble model of machine learning, all the machine learning classifiers for the shared task. So first, the system's process flow is first collect the code mixed data set for the training data set, validation data set, and testing data set. So first process, cleaning the each comments in the data set. The cleaning process involves removal of emojis, unnecessary words, some unnecessary word means some URLs or some hashtags, something, and stop words. So this is code mix data. So it may contain less amount of and or some English stop words, but we are doing the English stop word removal also, and replacing consecutive letters into single letter. This is one of the important, because we are seeing that in data set some words, some letters are in form of, for example, Talaiva is a word is that containing a in the end of the word is many times, but actually Talaiva is simply single a is enough. So converting multiple consecutive letters into a single letter is one of the cleaning process. Then converting the comments into TF-IDF vectorizer or custom word embeddings, because this is a code mix data, and so we cannot use any pre-trained word embeddings. So I have using my own word embedding using Keras. Then creating machine learning or deep learning models like Naive-Bayes, decision tree, random forest, AdaBoost using scikit-learn package, and LSTM using the Keras package, and the end creating the ensemble model by applying the max sorting of the above 4 machine learning models only. Then training of all the models using the training data, and validating against the validating data, and predict the class labels of the test data is the final one. So first of all, in the Tamil English data set contains 5 types of class labels, and each class labels has having an imbalance of the distribution of each class. So the class distribution is given below. The mixed feeling class having 11% of comments, negative comment having 30% of comment, and positive having 68% of comment, and non-Tamil comments are 3% of comment, and unknown status 5% of comment. This describe the data set is totally biased on the positive comments only. So we have to sort it out, this imbalance while on the training. So I'm using the weights concept on the machine learning training on the. So first machine learning model is a Naive-Bayes. Naive-Bayes is a probabilistic model. I cannot attach this because there is I don't use any hyperparameters, simply using the Naive-Bayes. So it uses the Naive-Bayes algorithm using the probabilistic vary. The training will be done and tested will be testing the testing data set. And second, the decision tree. So criterion is entropy for the splitting the nodes, and depth of the decision tree is 851, and number of leaf nodes are 6298. The second model is a random forest, which is one of the classical ensemble classifier, which is a collection of decision trees, and taking the maximum values, maximum output class, maximum results from the each decision tree. So I'm using the criterion for the splitting nodes is Gini, and number of decision trees to be taken in the random forest classifier is 10. And next one is AdaBoost. So AdaBoost is basically is a AdaBoost is also a one type of ensemble classifier, which is used to boosting some base estimator, some weak estimator to perform well. My decision tree classifier to be taken as a base classifier. I'm doing my I'm just boosting the decision tree's performance by the AdaBoost. So taking decision tree classifier as 100 times, though there are 100 decision trees were generated, then and the 100 type of decision trees are boosted with AdaBoost classifier to improve the performance. And I'm using the deep learning model LSTM using the Keras framework. I'm just using the creating my own embedding layer using the Keras packages embedding layer. The embedding layer contains the maximum number of features is 128, and then bidirectional LSTM layer with 128 by bidirectional LSTM nodes, and then fully connected layer or dense layer with 5 neurons, which reflects the output classes of the task. Finally, the ensemble architecture is for the training data will be pre-processed and generating the TF IDF vectors for the sentences. The TF IDF vectors for the sentences are given into the 4 classifiers for parallel decision tree, random forest plus decision tree. So random forest, naive and AdaBoost plus decision tree. The 4 models are will be given the 4 different output. The 4 different output will be taken as the max voting step. This is our finding the maximum result from the 4 results, and create the prediction variable, and it will be evaluated against the test data labels. So this is from the results obtained. So from our submission, naive is having a higher weightage, higher F1 score of 61% and accuracy 65%, and also at the same time LSTM having the same F1 source of 61%, and accuracy is 68%. But the LSTM having a the high precision, the naive LSTM have been say take second place. Naive classifier as first the high performance of the having a high performance classifier, and it will be ranked as a 5th rank. And also ensemble classifier is ensemble model is also performed well because it gives 60% of F1 score and 59% of average precision. So conclusion, we have achieved better results for the naive and naive LSTM and ensemble approach. In future, we aim to develop the mixed data specific pre-processing techniques to eliminate the ambiguity and redundancy of words, and also try to develop a custom multilingual pre-trained Tamil English word embeddings for the better results. So there's some references. Thank you, sir.
Okay, thank you, Hari Krishnan. Does anyone have any question about the presentation? You can post it in the chat or just unmute yourself. Okay, if not, then I have one question. You use ensemble approach and you combine decision tree, random forest, naive Bayes, and AdaBoost. So
Yes, sir.
I see you used both decision tree and random forest, which are necessarily similar, but one is better than other. Like random forest is the better version of decision tree, which uses ensemble approach. So is there a reason behind using both? Um, do you have any intuitions behind that?
Sir, actually, I'm the beginner in the this machine learning. So from so I'm just trying all the machine learning models which are performing on the validation data. So the ensemble model is but random forest is simply one machine learning model is not enough for the ensemble architecture. So I just taking decision tree also.
I see. Okay, that's fair. There's one more question, like when you're doing max voting mechanism, what if you have conflict between like four classifier predict four different classes? In that case, how do you solve the conflict? Like which label you will select as a prediction?
Sure, so I'm doing the not using the inbuilt voting classifying the ensemble voting classifier. So just taking manual procedure for the voting concept, taking the four classifier results and taking row wise mode values.
Okay.
So I was defaultly taking the mode values of the results.
Okay. Okay. Yeah, that's fine. Okay. If there is no other question, then we can proceed with the next presentation, which will be given by Supriya Chanda.
Can you just stop, sir?
Yeah, you may stop sharing your screen. Supriya,
Thank you.
can you go ahead with your presentation?
So, am I audible?
Yeah.
So, very good evening to all. I am Supriya Chanda. I am going to describe the IR lab at the top IIT BHU system for sentiment analysis of Dravidian language pairs. So what is the code mixing? The code mixing is described as the embedding of linguistic units such as phrase words and morphemes of languages into an utterance of another language. So code mix data is generally observed in the place of informal communication like social media, YouTube, Facebook, and all. And code mixed have many tasks like word label task, sentence and sentence pair, like language identification, POS tagging, name entity recognition, and sentiment analysis, question answering. So in Dravidian language, sentiment analysis for Dravidian language shared task description uh, it's a message label polarity classification task. So they given a YouTube comments and we have to classify it in these five classes like positive, negative, neutral, and mixed emotion. And for Tamil it's non-Tamil, and for Malayalam it's non-Malayalam. So this is the data statistics given by the CRTAS organizer. So you can see that this is not uniformly distributed. So there is some imbalance in classes. Like positive we have 10,559, and non-Tamil it's 497. So uh, so the classification, so these tasks is measured in this three evaluation in the three evaluation, like weighted device precision, recall, and ape score, and the rank is based on this weighted average F score, F1 score. So so this is the data example, and after pre-processing, so what we did in pre-processing, we removed this consecutive many character, the consecutive character we skew it, and like after pre-processing we eliminate this saliva. After all A, we remove this all A and keep this one. So wow, wow, Thalaiva, proud to be very Indian. Thanks to Shankar, sir, and team. And we use we use this pre-trained model like BART and digital BART and fast text.
Hi, Supriya. I'm not sure if anyone can listen to you because I can't. Can anyone from co-host listen to Supriya? I don't think he's audible.
I think he may have faced some network issue.
Okay. Mm-hmm.
I think it's better that we move ahead if that is the case.
Okay. Then the next presentation was planned for Parameshwari. Are you ready with your PPT? Are you there?
Yes, now she is for.
Okay.
Hello, yeah, can you hear me?
Yeah.
Yeah, thank you so much. Let me share my screen. Okay. Just so are you able to see my screen?
Yeah.
Yeah, thank you. So I'm Parameshwari Krishnamurthy. Yeah, I think good evening to all. So yeah, I think we are the only group who are coming from non-technical background. We are from Center for Applied Linguistics and Translation Studies from University of Hyderabad. So this is the first time we have attempted to build a approach using machine learning technique. It's a first attempt, of course, and using n-grams in sentiment analysis for code mixed text. And we have used Telugu and Tamil database, which have been given in this task. So yes, Tamil and Telugu, they are widely used languages in social media in different domains. Definitely they need a robust sentiment analysis, and more than 47% and 27% respectively, like Tamil and Malayalam, are being used very actively in the internet. So this provides us kind of strong motivation for taking up this task. And again, Tamil and Malayalam are two major Dravidian languages and known for their linguistic feature called agglutination, very rich in their morphology. And here word contain multiple morphemes attached to the same stem with distinct morpheme boundaries to form a multimorphemic word. So we thought that since we are from more of linguistic background, we thought that initially we thought we'll inject a lot of linguistic features to the machine learning, then we'll start doing that one, because understanding the inflection and derivational system of a language is very crucial in sentiment classification. So this is the data set we got from FIRE. And as others have also noted, it's a really imbalanced data. So a lot of data being given in the positive side, both in Tamil and Malayalam. So the technique that we have used is we have done some kind of pre-processing and have used some n-gram modeling, and we have converted into weighted features, and there's some kind of machine learning here. So this is what we have done in the pre-processing stage, which involves the data cleaning. We have removed the stop words, punctuations, numbers, and non-Unicode characters. And we have also, since the data set is given in the Roman script, we have converted it into the lowercase. Because in a lot of times the words like talaiva, it starts with a capital T, sometimes with small t. So to just balance that thing, we have tried to convert that into the lowercase. And we have created an n-gram model using the pre-processed trained data set. Bigrams and unigrams are identified with the highest probabilistic sentiment category. So the unigram and bigrams, bigram databases are more likely 18K and 58K respectively in Tamil, and in Malayalam 12K and 28K in unigram and bigram respectively. And each sentence is converted into unigram and diagram model based on the maximal match. And we have converted into this data thing has been converted into TF-IDF features, and this has been passed on to and we actually, before going into the TF-IDF, we have even tried bag of words approach, and we observed that TF-IDF gives better results than the bag of words. And then since it has it deals with the classification of text into positive, negative, unknown state, mixed feeling, and not Malayalam or not Tamil. So we have used multi-nominal naive-based algorithm to classify the text into categories. As we have seen many papers which talks about this model works efficiently when there are multiple categories with a combination of IDF features. Then this is the kind of model that we have tried, and this is a kind of like unigram and bigram conversion data that we have used. So the initial text is being converted into bigram and the unigram based on the currently how many time it occurs as a positive or negative kind of thing, and based on that one we have selected the highest frequent one for our text. And this is the training data set we got. Again, there is an imbalance in the data set. Of course, again, the positive occupies the highest position. Whereas in Malayalam, again, we have seen the unknown state is the highest, next highest state. Whereas in Tamil, the negative got 13.47% from the trained data set. So this is our research, though results are not so promising. It's our first attempt. We thought, okay, it's fine. So some of the discussion we would like to put over here is in the case of identifying positive category, our model performs really better due to the data size. Whereas in identifying other categories, definitely there is a failure. And again, we have also noticed that in annotated data also there are some inconsistency, which we understood because, working with the YouTube kind of data, building a very effective or efficient data set is really a cumbersome task. To name something, for example, in Malayalam, there are something like proud to be Viyappin curry. So it was actually annotated as not Malayalam, but our model has given as positive, which we thought that positive is much more appropriate in this stage. Similarly, in Tamil, you can see the sentences like I'm Simbu fans like Dhanush acting, which is annotated as positive, but our model has given it as unknown language, not Tamil, but actually it is annotated as positive. So which we thought, okay, this is an inconsistency in the annotation also. Similarly, there are many cases, more than 20% of, after analyzing the data, we found that there is a kind of inconsistency, which we thought as a positive or a negative, which is not annotated similarly as we have expected. So another inevitable reason, of course, the failure or the low accuracy in our model is the database improvement that is required. So we need to have good n-gram data, and its size is really low. So Now, the model accuracy can be improved with the increasing of the database of the milligrams and bigrams. And to further improve the model, of course, spelling normalization of code mix data and integrating some linguistic methods, especially we have initially tried to use some kind of inflection, removing inflection and derivational markers, sometimes using some kind of negative suffixes like in Tamil and Malayalam, which are very rich in their morphology, and use their negative suffixes along with the verb especially. So initially we tried that one, but we couldn't actually implement that one. So in the future, we would like to use a lot of linguistic information injecting with what kind of whatever machine learning that we can do. We'll try to do that one. So although this requires a lot of data and accurately human classified sentences to improve the accuracy of machine learning model. So the distribution of sentiments equally in the trained data set is another important aspect, which could easily maybe do better in the machine learning, which we are actually exploring. Yeah, that's it from our side, and thank you for allowing us to participate in this track. Yeah, thank you so much.
Thank you, Parmeshwari. If anyone from the audience has any question, you may post in the chat or.
Hi. Thanks, Parameshwari, for the nice presentation.
Yes.
So yeah, so your study about the data sets and annotation was really good, but the problem was when we are asking annotators to annotate, even they were not sure whether that sentence was English or Tamil, because when you see the Simbu sentence that you have showed as the example, where it says like, I am Simbu fans like Dhanush acting positive, so that kind of, because of the people started using the English as their own language in the own word, sometimes they are not able to differentiate whether this is Tamil or English. So that kind of problems we are also facing. So this is a really good study from your side. So if we are also running the Dravidian language workshop in EACL. So if you could extend this linguistic study and write paper for that also, that would be a great one.
Yeah,
Thanks.
thank you. Yeah, definitely.
Okay, if there is no any other question, then we may proceed with the next presentation, which will be given by Prakash Babu. Are you ready with your presentation?
Hello.
Yeah.
Yeah. Am I audible, sir?
Yes, you are. Yeah.
Sir, is my screen is visible?
Not yet. Yeah, I can see now.
Yeah. Good evening, everybody. My name is Counterpart Prakash Babu, and my team members are R. Ishwari and K. Nimi. We are from NIT Trichy, India. Actually, my title is Malayalam English Code Mixed Sentiment Analysis using Sentence Bed and Sentiment Features. This is my table outline, introduction, pre-processing steps, and the proposed model, results, conclusion, and references. And next, I'm coming to introduction. Actually, code mixing is the mixing of language while writing text. Here, the people are, previously, everybody, when they are using normal mobiles like that, they are using English text while they are going to type messages like that. But now the days are going and everybody like to speak in their own language, and text also they are going to write in the same language. And actually they are not using the same script, but they are trying to write the script in English. Actually, that is the problem here. So previously, so many models are there to identify the English, and next they are to identify the grammar and to predict the next sentences. And if you give if you ask any question for answering that question, that is possible for nowadays models are implemented in that. Those are performing very well. But when coming to this code mixed things, it is not that much easier. But nowadays only it is going to come in for research. They are giving more interesting to analyze this type of messages. So here in Dravidian Code Mix 52020 is this shared task organizers took this issue and they are trying to solve this thing. Okay, it is very good task. And here they gave sentiment analysis. Those are positive, negative, unknown state, and mixed feelings, and not Malayalam categories they gave. In this we use sentence level bet and Manglish features, and we got FN score of 71%. Okay, here to solve this, actually the YouTube comments like that, it is human generated things. That's why there will be some extra characters they will come, and they will use, instead of words they will use some emojis, and sometimes they will use extra characters, and spelling mistakes like that it will come. So to solve that things, we use some steps. That first one, we convert all the things into lower cases and removing the special characters because they don't have any certain importance. So, and next, emojis, we replace the emojis with the related emotion word, because here it is Dravidian. Actually, people are using happy, bad, sad, like that, and cry. These type of things they are using with symbols nowadays. So this is sentiment analysis. So we try to extract from that emojis also. That's why we replace like this. And one more thing, removing the repeating characters from the words. Actually, some people, if somebody have so much of excited, then they will say hi like that, HAI like that they will write, and they will write something bye like that, BYE like that they will write. So for that it is not that much easy to do that type of things. Actually, we thought we observe one thing in English, there will be extra 2 characters is enough like that. So instead of 3 extra characters, we took only 2 characters from that. So we did pre-processing like that, and coming to the statistics of the data set. See here labels are there: positive, negative, not Malayalam, unknown state, and mixed failings. In this, if you see this data set itself, we observe that some imbalance is there. So here from this one we observe here we got 2 challenges. That is, one thing is to observe sentiment analysis from the code mixed sentences from YouTube, and to do something for imbalance for this imbalance to solve this issue. Okay, and next coming to for this we proposed 2 models. The first model is we use base sentence bet. Sentence bet actually, and with Manglish features. Actually, Manglish features means we observe some sentiment words from the Malayalam, and we write it in like a Dravidian code mixed language. In English, we write it in English. That we observe 252 Manglish features, and we gather them from YouTube comments actually. And that future vector is generated from every comment. Actually, we took every comment and we create one hot encoding for every comment. After that, we took representation vector from SBAT and feature vector, that is one hot encoding further, and we combine this thing and we gave it to soft fact model, and it gave required label. And this is the my model on architecture. So we did pre-processing, and from SBAT one representation model came, and after pre-processing step we gave this thing a feature vector, and we combine both feature representation vector and feature vector, and we give that both combined, and we give it to softmax layer. This is about model 1. And come to model 2. Actually, for challenge, we took one more challenge, that is class imbalance is there for actually in that. So to solve this thing, we took baseline model, that is base SBUT or sentence BUT, and instead of class entropy, cross entropy loss, we use class balancer loss. It's used to handle this imbalance issue. Okay, and this is my model 2 architecture. Actually, here after representation vector, here before going to softmax layer, we gave to class balance loss. After that, we gave to softmax layer, and it gave predicted label. So these are my results. Here we experimented on SBUT and SBUT with the feature vector and SBUT with the class balancer loss. Here we got SBUT with the class balance loss highest, but when compared to SBUT with the feature vector, it is very minimal. It is very less amount we got. But here we didn't add any feature vector for the class balance loss. Just we use sentence BUT, and from that representation vector we give it to class balance loss. We calculate class balance loss. For that itself we got 71% instead of feature vector. And one more thing, for baseline model SBUT we got very less, that is 61%. And next, coming to results analysis, here class wise, this one is accuracy metrics for SBUT and evaluation set. Here in mixed feelings we got a very less for SBUT, and for positive 67, and not Malayalam we got 71%, because it is a model is unable to find. I think maybe some English words are there in that. That's why it gave good results for not Malayalam, I think. Okay, and next, when compared to accuracy metrics, metrics for SBUT with the feature vector, here we got for positive 76% we got F1 score, and for not Malayalam we got 78%, and unknown state we got 69%, and negative and for mixed feelings we got 42%. See here, for when compared to when coming to SBUT with the class balance loss, we got 79% for positive tweets, positive comments, and not Malayalam we got 78%, and for negative also somewhat it increased, and mixed feelings we got less. Actually, for mixed feelings, for sentence BUT also, for sentence BUT with the feature vector, actually it got confused. There will be a confusion, because even though we gave one hot encoding also, there will be good and bad things will be there. That bad words will be there. So negative words will be there.
Sorry to interrupt. You have 1 minute left. Can you please wrap up?
Yes, sir. Yes, sir.
Sorry.
Okay, so that's why a model is unable to find this, much. It is unable to get that much accuracy. And coming to conclusion, actually, we use this paper presents to. Okay, actually, this task is treated as multi-text classification problem. The model based on SBUT with the CBL achieved F1 score 71%. In future, we will improve the model to find the sarcasm Manglish comment. Actually, for mixed feelings, it is unable to find that. It is unable to get that much accuracy. So we want to work on that. These are the references. Thank you. Anybody have questions? Please ask me.
Yeah, thanks, Prakash. If somebody has question, you may post in the chat or unmute yourself if possible. Okay, if there's any question, we can proceed with the next presentation, which is by Suman. So if you are ready, Suman, then can you go ahead with the presentation?
Yeah, yes, thank you. Hello?
Yeah, Prakash, can you stop sharing screen?
Yes, sir, I will start.
Yeah, yeah.
Yeah. Just a second. Is my screen visible?
Yes.
Yeah, hello everyone. I am hello everyone. I am Suman Dolagar. I am here to present the work of CMSA1 team on shared task, Dravidian code mix, a sentiment analysis on code mix, Dravidian text. So all of you know what is code mixing. It is a simple mixing of two or more languages in a sentence. It is practiced in day-by-day conversations and also on social media platforms. Code mixing is simple for us, but challenging for many machines, for NLP machines. Why is it challenging? Because the current generation NLP machines are trained on book corpus. All the fundamental problems of text classification, language modeling, sentiment analysis, information retrieval, and extraction of embeddings, all of them are done in book corpus. Why? Because the corpus is pre-processed, means it is spell checked, grammatically corrected, and organized. But the real-time code mix conversations or comments doesn't follow a grammatical structure. That is, real-time code mix comments doesn't have a spell structure and they are emotional. For example, the word talaiva is written in the given formats, talaiva, talaiva, and tala. The way of expression of those words puts forth the emotions. And as no two emotions are same, no two code mixing is same. And also it consists of hybrid words, such as I am from Telugu background, so I will quote Telugu word, code mix word, that is bassu, B-A-S-S-U. And it means bus. Morphologically, extracting even the root of such words is difficult, as the words are even changed at root level. So it has no proper script. The sentence and or words are written at Roman level or a combination of the given languages. So it has no proper script. And as the current generation state of the art NLP machines are trained, are based on script and syntax, it is a challenge for them to understand the code mix sentence that has no linguistic rules, no script, and follows and doesn't follow a grammatical structure. And this current task is devoted to code mix sentiment analysis on Tamil and Malayalam languages. These tasks aim to classify the given code mix YouTube comments about movie reviews into predefined 5 categories. Such tasks helps to analyze the real-time comments and helps to rate the movie based on the reviews. The training data set consists of more than 15,000 Tamil YouTube comments and more than 6,000 Malayalam code mix YouTube video comments. And this is the architecture of the proposed model. And we have used fast text, Elmo, and TF-IDF as meta embeddings with transformer and final feed forward layer for code mix sentiment analysis. You can see that. The tokenizer used is the subword level tokenizer because, as everyone said, and also because of the above challenges of the code mix data, we have opted for tokenization at the subword level. And we have used sentence piece token, subword level tokenizer. We can see the sentence piece usage in BERT-like models and in the Hugging Face library. After subword tokenization, we used a combination of embedding models because there are no pre-trained embedding on the code mix data, and because of data variations, we cannot rely on single type of text representations, that is embeddings obtained from a single model. Hence, we focused on 3 different type of text representations. They are fast text, Elmo, and TF-IDF. A neural network model trained on the given 3 text representations must learn the which text representation suits the best for the data and take that representation. As we have used 3 text representations, fast text captures
text representation and local dependencies at the word and subword levels. Elmo captures text representations at the sentence level, and TF-IDF factorizer captures distribution of words in the corpus. These are the text representations used, and they are combined. As the fast text representations are at the word level, so they are passed to the transformer model. And we have implemented a vanilla transformer model, which has a series of encoder layers stacked on each other. And the encoder layer has self-attention, layer normalization, residual connections, point-wise feed-forward networks to encode the given output. And then it is finally, and a stack of encoder layers, then it is finally passed to the GRU layer to get the final encoded representation of the given sentence. This sentence representation is combined with the two other sentence representations. They are Elmo and TF-IDF, and they are finally passed to the feed-forward network for classification. So the fast text model is obtained from GenSim. And it is used for obtaining the fast text model from GenSim library is used for obtaining the fast text embeddings. The Elmo model is obtained from the TensorFlow hub. And as the Elmo vector gives the dimension is equal to max pad sentence into 1024 hidden size, we took the mean of embeddings in order to obtain the sentence level embeddings. Then the TF-IDF factorizer is obtained from the sklearn module, sklearn library. And also it is at sentence level representation. The PyTorch library is used for developing the transformer model, and the following are the hyperparameters. And we have used Adam optimizer and cross entropy loss. And the following is the performance of the BERT model when compared to the other meta-embedding and Elmo models. The given meta-embedding model gave us the best results for what we have analyzed. So during the error analysis, I have observed that transformer model tried to overfit the positive class when compared to the other classes. And I have also observed that there is sarcasm included in the comments, which forced the classifier to learn the positive class, to lean to the positive class. This resulted in reduced accuracy and reference score when compared to the best ranked models. I feel that using the sampling techniques, we can balance the classes, and also by using sarcasm information, we can help to improve the performance of the classifier. So these are some of the important reads in order to understand the paper. Thank you, organizers and everyone. I have enjoyed competing and presenting in these tasks. Any queries?
Thanks, Suman. If anyone has query, you can post in the chat or just talk it out if possible. If not, then I have one query. I see you have used basic transformer model with stacked encoder, and you compared performance of that ensemble with BERT as baseline.
Yes.
So I was wondering, why didn't you use BERT representation instead of transformer? Because that is bidirectional, but transformer is not. Is there any intuition behind that? Or?
Yeah, actually, I think actually, I really think that the data is slow. So BERT representations are generally designed to handle large text representations. So I used the lower version, like I used only 3 stacked encoder layers instead of BERT. And it took less time when compared to BERT.
I see. I see. Thank you. So if there is no any other question, then I think that was the last presentation. And I would like to thank everyone for joining us in the shared task. And it was great seeing everyone's system presentation. And I would like you all to invite to one of our EACL workshop, which is similar to this shared task about identifying offensive language in code mixed Dravidian text. So for the reference, I'm just posting it in the chat. Free feel to join this competition, and the papers will be published in ESCL proceedings, workshop proceedings. And yeah, that is it, I think. Again, thank you all. And yeah, we may conclude the session, I think.
Thank you, Shabdul. All right. So, yeah. So this concludes the track presentations of the code mix track. Next, we take a 5 minutes break, and then we have the first invited talk of FIRE 2020 by Dr. Ellen Lewis. So, see you in 5 minutes. Hello, Dr. Boris.
Hello.
Yeah, it's pleasure to have you in FIRE 2020.
Yeah. Thanks.
And yeah, actually, I read your paper on the first IR track in having a first retrieval task in TREC as well. Actually, Prasenjit sir introduced it to me, so it was a very eye-opening thing for me.
Thanks.
All right, so let's begin. You can share your screen and
Okay, you want me to share it now?
yeah, and let me just announce. Okay, hello everyone. Now let's begin with the first invited talk by Dr. Ellen Burris on TREC COVID building up pandemic IR test collection.
Okay, thanks very much. It's actually morning here for me. It's about 9 o'clock in the morning, and it's bright and sunny after a miserable day yesterday where we had snow and rain and freezing rain, and it's really bright outside now because all the sun is shining off the snow. It's probably very different from many of you other places, but I'm very happy to be able to be with you virtually. This is actually my first time at FIRE. And so I want to talk to you today, or I was asked to talk to you today about the TREC COVID test collection that we built, and sort of explain how we build it and why we build it, and what it tells us about building test collections. So just to make sure that we're all on the same place, here's my definition of a test collection. It's a set of documents, a set of relevance assessments, and a set of questions or topics. And the relevance judgments are the hard part of this. Ideally, you want to have complete judgments, but that's unfeasible if you have a large enough document set to be interesting. And so therefore you need to sample in some way. Now, obviously we all know this, right? This is the whole point of the evaluation campaigns such as TREC and FIRE and CLE and NTCIR. We're all trying to build these test collections as the infrastructure to help people do their research. But what we want then, or at least my problem statement here, what I want when I'm building a TREC collection is I would like to have a general purpose collection that's reusable, and I have to build it at an acceptable cost. So by general purpose, I mean that I want to be able to support a wide range of measures and search scenarios, because if there's one thing that I've learned, is that if you build a collection, people will use it, and they'll probably use it in different ways than you expected it to be used. And the more different ways that it can be validly used, the better you're supporting the research. But the problem there is it has to be a valid use of the collection. And so therefore, when you're building it, you want to build it such that the collection will support these variety of uses. You want it to be reusable, which means you want it to be fair to or unbiased to systems that didn't participate in the building of the collection, right? You would really like to be able to build a collection once and then hand it off, and no matter who uses it for that task, that they have an unbiased scores that come out for their system. And for the purposes of this talk, the cost is going to be proportional to the number of human judgments that are required. That's not always strictly true that the number of human judgments is the dominating cost, but it is usually the dominating cost. And so for me, cost is number of human judgments that I need. So the original way that TREC built its collections was through pooling. Pooling was introduced back in, actually, I guess it was the late 70s, by Karen Spark Jones and Keith Van Rijsbergen. But it didn't actually get implemented until the first collections in TREC, and that would be the early 1990s. And the idea behind pooling is that we only want to look at documents that we think are likely to contain relevant documents, right? If we can't judge the entire collection because the entire collection is too big, we have to sample somehow. And the way that we sample in pooling is just to say, okay, we're going to have a whole bunch of different runs. These runs are going to be ranking the documents in the order that they think are most relevant. We'll take the top some number, here I called it lambda, the top lambda run documents from each of these runs, and we'll look at only those. Importantly, when you're computing relevance measures, when you're computing effectiveness measures using the relevance judgments, when you're using pooling, you assume that any document that was not judged is not relevant. Okay, because the whole idea here, the whole point of pooling is to say we're going to find the vast majority of the relevant documents in these top ranks. And so if we didn't look at it, we're going to assume it's not relevant because none of these retrieval systems retrieved it. And we've looked at the quality of the collections that get produced that way, and they have generally been okay. They've been both fair and reusable. By fair meaning that they didn't discriminate against runs that did participate in the building of it, but they were reusable also in that they didn't discriminate against runs that didn't participate in the building too. That was until the collections got big enough. And now if you just took the top lambda documents, when the collections were too big, when you take only the top lambda, say the top 100, which is what TREC used documents, you're always within the same type of relevant documents within those top ranks. For example, and this was the example that we found in the robust TRAC collection that we first found this problem on. Most retrieval systems are going to retrieve documents that have topic words in them first, right? That's a sensible thing for the systems to do. And if you have a large enough collection, then all of the set of documents that contain a topic word is going to be bigger than your pool depth, which means you're never going to be able to find those relevant documents that don't have a topic word in it. And that's a problem, because if you come across some system which for whatever reason is able to find those documents which would have been relevant had somebody looked at them, but they didn't have topic words, you'll never know that that system is actually doing something really good in finding unique relevant documents. And so what do we do then? Well, we can't keep making our pool sizes deeper and deeper because that gets too expensive. And the collections aren't getting smaller, right? The collections still keep growing. So now we have to sample in some different way. And there's been a variety of different, I'm sorry, can I ask you here, can you see this little box that's on the right at the bottom? On my screen, there's a little box here on the right, and I want to make it go away if other people can see it.
No, it's not visible.
Okay, good. All right, thank you. So there were a couple of other, so once we solve this problem with pooling, people have come up with other ways of building collections. And I want to put out here that the goal actually is not to find the most number of relevant documents possible. Right? You see that in some papers, and those papers are wrong, right? You do not want to find the most relevant documents you possibly can. What you want to find is a fair set of relevant documents. And I can give an example here of one of the methods that we tried building collections with, or it was a set of methods based on using multi-arm bandits optimization techniques. And these multi-arm bandit techniques basically every time each of the runs is an arm of the bandit, and the bandit method goes off and selects which document to take from which run next, and it sticks with the same run as long as that run returns a relevant document. So here's a case, this in the multi-arm bandit methods, you select which document is going to be judged next based on judgments that have already happened, right? So this is a dynamic process. You have to have the assessor actually in the loop. And when they make a judgment, the sampling system decides which document they're going to judge next. And what the multi-arm bandit methods do is they select another document from the same run that they just took the relevant document from, as long as it was relevant. And they'll just keep returning the same document, this documents from the same run, as long as they keep getting relevant documents. That's a sensible thing to do in terms of maximizing your number of relevant documents you will find. But if the number of judgments that you can have is small relative to the number of relevant documents that there are, that's a very unfair process, because all these other runs might have relevant documents also, but you'll never get to them because you have just stuck with this same run because it keeps returning its own relevant documents. So TREC did try building collections using these multi-arm bandit methods for 2 years, and we stopped because of this unfairness property. And the problem is it's unfair, but you can't tell that it's unfair unless you go looking for the problem. And you can't tell that there is a problem unless you use more judgments. In that case, you're now having to use judgments to check the quality and not based on building the collection itself. The inferred measures is another way of building collections, and that's fair. And the quality of the collection is reasonable as long as you define the way that the particular sampling method that you use reasonably. But the problem there is it's not general purpose. You have to use specific measures, and you have to calculate those measures in specific ways. And the relevance judgments have to come with all these different, the remainder of the layers in which the measures were, the documents were drawn, the strata from which the documents were drawn have to be part of the relevance judgment, the QRELS file. And that gets complicated, and people don't use it as much and as correctly as they should. And a technique that we've been trying to do in TREC recently is using what's called HiCal. HiCal is a system that was developed at the University of Waterloo. It's also a dynamic method, which means you have to have the assessor in the loop doing dynamic assessments. And what HiCal does is, given a judgment or given a set of judgment, it builds a model of what a relevant document looks like. And then that model within the HiCal selector itself picks the next document to be judged, with the idea that the model that it's building from the previous judgments is building a model of relevance, and so therefore it can find documents which are likely to be relevant, and you'll judge those next. It is more fair than the multi-arm bandit methods because it does not rely on any individual ranked list. However, and this is a problem that we don't know, we're not sure whether or not it is unfair to methods which are unlike the model that HiCal itself builds. The University of Waterloo has looked at this problem, and actually I've looked at this problem some too, and so far I have not found any problems with building collections this way. But that's still a worry of whether or not you're going to be biased against unusual methods. So that was the whole background into which we entered, or I'm sorry, let me interrupt myself here. I want to talk about also how do we know whether a collection is good or not. And unfortunately, we don't really have good tests for this even yet. All the tests we have can show problems if they, or if the test shows that there's a problem, then there's a problem. But we can't categorically say there is no problem just if these tests don't show it, because all of the tests that we have depend upon the runs that we've gotten when we built the collection. And obviously, if we use those runs to build the collection, then the tests we have are unlikely to be showing future problems. But two tests that we have used, there's this leave out uniques test. And in this case, this one was originally developed when collections were built by pooling. TREC had used some of this test. Justin Zobel in his 1997 CLEF paper introduced a similar variant of this test, which is you pretend that one of the teams that participated in the collection building didn't participate. And the way that you pretend that is you take away all of the documents which that team retrieved and were judged relevant, and only that team retrieved. So you take those out of the judgments, because if that team hadn't participated, then you wouldn't have had known that those documents were relevant. And you reevaluate everybody's runs to see how much those runs changed without the judgments caused by the uniquely retrieved documents from that team. And then you repeat that for all teams. Then once you do all that, there's two ways that you can look at this. One is just to look at the Kendall-Tau or some other measure of association between the system rankings, right? So if you take the full QRELs and see how it ranks the systems, and then you, by some measure, and you take the system ranking by that same measure, but produced using the QRELs where the uniquely retrieved relevant were removed, and you just compute the Kendall-Tau between those two lists, and you want that to be high, right? You want that to be like above 0.9, which is almost perfect, because Kendall-Tau runs between -1 and 1, where 1 is the maximum value, meaning that the rankings are exactly the same. However, because there's lots of runs, and most of those runs aren't going to be affected majorly by losing a few documents, the average behavior of the Kendall-Tau, it generally looks fine. So in fact, what you probably want to do with the leave out uniques test is look at the maximum drop from any one particular run when those relevant ones were removed, because it's that team or that run that is maximally hurt by the removal of these relevant documents that is the interesting case. A different type of test to look at whether a test collection is of quality is to take your set of topics, take a random subset of those topics of some size, S, take two random subsets of that same size, and look to see if those two random subsets of their topics rank the systems the same. We know that this ranking of systems on smaller subsets will change the ranking somewhat. The smaller S, right, the smaller this subset is, the more changes you'll have, because we know that test collections are stable only when you have enough topics for the law of large number averaging to kick in. But if you have some particularly bad topics, then these subsets will be more unstable than if you have all the sort of the normal diversity among topics. So I'm going to get into the results for those two tests later on in the talk, which is why I wanted to bring them in here. They're both test of collection quality. And as I said earlier, they're only so good as if they show a problem, there's a problem. But if they don't show a problem, you're still not guaranteed that the collection is okay. And we don't have any better tests than those. All right. So in this background to all that, in March of this year, the Office of the Science and Technology Policy, it's OSTP, which is a subdivision of the White House here, in the US, issued a call for people to use for the research community to support the research into COVID by using a document set that OSTP had contracted to be developed. And this document set that they had contracted to be developed was, they open sourced the literature on COVID-19. And the call went out to the research community in general, but they made a sort of a specific appeal to the federal agencies, and NIST is a federal agency in the US. And so we said, yes, we will try and build a test collection for how people search the literature on COVID-19. How do people search during a biomedical crisis? Why would we need such a thing? We already have test collections that have scientific articles, so why would we need a new one? The problem that we saw is that the way that people search the scientific literature during a pandemic is actually different from other types of scientific literature search. And the main problem there is the literature in the area explodes, but it explodes in a different way than traditional scientific literature search is used to, because most of the literature is not peer reviewed when it first becomes available, right? It's now being published in archive sites and in other gray literature areas. And so you not only have the problem of it being new and of it being, so the vocabulary and everything is new and it's growing very quickly, but you also have this problem that it's not vetted, which means sometimes it's being retracted and other times it's just flat out wrong. And you as a researcher, a biomedical researcher, are trying to find the best answers that are actually correct that you can. And so our goal was to capture this whole churning process into a test collection that people could then use to build systems that would help in future crises. And so partners in all of this was NIST, and that was the TREC group at NIST. And the Allen Institute for AI was the main organization tasked by OSTP to maintain the document set. And this document set is known as CORD-19. And so Allen AI issued, originally it was weekly updates to the CORD-19 data set, this open source literature. But along about end of May or so, they went to daily updates. So this collection, there's a new document set every day. And we wanted to try and capture some of that. The other three partners are all partners whom TREC has participated in the past with in other medical tracks within TREC. And they all have medical experience. So this is the Oregon Health and Sciences University, the University of Texas Health Center, and the US National Library of Medicine. Because we were trying to capture this way that the literature was expanding and that people's ideas of what they should be searching for, et cetera, were expanding, and the CORD-19 document set was being re-released, we structured TREC COVID as a series of rounds. And each round was like an individual track within TREC. So we made the document set available, we made topics available, we got relevance judgments, or we got runs in, we created relevance judgments from those runs, and we scored those runs, and then we announced the results for within that round. And we did that 5 times. We had a total of 5 rounds in building the final collection. The questions that we used as topics came from search logs from medical libraries, and mostly from the National Library of Medicine. And the judgments were being made with people with biomedical expertise. And those were found by those 3 medical partners that we said. So some of them were National Library of Medicine indexers, and others were informatics, bioinformatics, PhDs, and some of them were MDs. So here's an example of 3 of the topics that we used. We started with 30 topics. So round 1, we had 30 topics, and then we added 5 new topics for in each round. And so that by the end of the 5th round, we had 50 topics. And we tried to balance the subject matter of the topics between bench science and clinical science and public health. So the public health questions were more along the lines of what you might expect consumers to be asking. Sort of, what's best practices for quarantining. The bench science was more about the actual, so topic 36 here is an example of that. What they want is, specific information about the protein structures of the spike part of COVID, or of the SARS-CoV-2 virus. And clinical science was sort of how best to treat people with COVID. And here's one, what's the best treatment for this particular type of the dexamethasone, which had a lot of misinformation about it out. Probably one of the most notable things about TREC COVID was the speed at which all this was happening. So we released the first round 1, we released the first set of 30 topics and the document set on April 15th. And participants had to return their retrieval results by April 23rd. And they did that in the same way that they do it for TREC, which is they submitted their ranked list of documents to NIST. We actually got 56 teams to do that, which I thought was phenomenal response, frankly, because they had essentially 10 days in order to bring up a system and deal with the COVID-19 document set and get results. And after we got the results from 143 runs from these 56 teams, we then had about 10 days to 2 weeks maybe to get relevance judgments. And given the number of assessors we had and the amount of time we had, the actual number of judgments that we could make in any one round was limited. And for that reason, if all the experience that we've had through TREC and new ways of building collections, etc., we ended up just using pooling, and we used pooling at very tiny ranks. So for round 1, for example, we pooled to depth 7, which is very tiny, but that was all that we could fit in the allotted time. Now, of course, the rounds continued, and so we got more and more judgments as time went on, but each individual round only had a very small number of judgments comparatively to the size of the collection. By the end, we had 50 topics and we had about 70,000 judgments. There were probably throughout the course of the 5 rounds, there were about 90 distinct teams that made submissions. It's hard to tell because people didn't actually have to, when they signed up, they just gave us a name. And so if they used 2 different names, we wouldn't necessarily know that they were the same team. And we had, roughly 500, maybe a little less submissions across the 5 rounds. Now, one of the things which you may have been thinking is if we use the same document set, right, Cord 19, we just kept using the later and later releases of Cord 19, and the topic sets were also subsets of one another, right, because we started with 30 topics and then we added 5, but we kept the whole set. These collections, we made relevance judgments available for each round before the next round started. And so if we just let systems retrieve anything they wanted, any sensible system would have just kept returning those documents that had been judged relevant already, right? You want systems to use this feedback, that these relevance judgments, but you don't want to have people training on their test data. And so what we needed to do is we needed to use residual collection evaluation. Residual collection evaluation is a very standard technique. If you look in the literature in the late 80s on how people did feedback evaluation, residual collection is right up there. It's simple to understand and it's simple to do. And what residual collection evaluation means is if a document has been judged in any prior round, it is considered not part of the test set in a later round. Okay, so if document 1 was judged for topic, well, if document A was judged for topic 1 in round 1, then document A was not part of the collection anymore for topic 1. It was still part of the collection for other topics, but it's no longer considered part of the collection for a topic for which it was already judged. So residual collection has lots of benefits. It prevents gaming of the metrics, even inadvertent correlations that can happen. It depresses the absolute values of the scores sometimes, but that's not really an issue. Especially in this particular collection, because this particular collection has lots of relevant documents, and we'll get to that in a moment. It does mean you have to keep track of which documents were judged in which round, and that bookkeeping is important to maintain. The biggest problem with using residual collection evaluation is that it means that each round submissions, right? So as the submissions came in, they could only be evaluated using the relevance judgments we made for that round. We couldn't use accumulative relevance judgments because any document which was judged earlier in an earlier round was not part of the collection, and so therefore it can't be part of the evaluation. So that meant that each individual round was judged on a relatively few number of documents. There was another problem though, and that was the document set, the Cord 19, was each version of the Cord 19 that we used in later rounds was not in fact a subset, a superset of the previous rounds. And that's because of the way that the document set kept changing. We knew going in that it would change and that it kept growing, but what we hadn't really anticipated, or at least what I hadn't anticipated, was that it was much more than just the collection was growing. The documents themselves were changing. Sometimes when a document got published in a new area, it was removed from the archive part of the collection because now it was in the public literature part of the collection. And so documents were removed from the collection. Documents that had already been judged were removed from the collection. And so this even more significantly complicated the bookkeeping, because in order to do the scores correctly, you had to know precisely which round of this run came from, what version was of Cord 19 it was used, and you had to remove some of the relevant, you had to rename some of the documents, and it was pretty complicated. And that was a complication I had not anticipated. It means future use of the collection will also have to be careful to use that correctly. I've said a lot of this already. The per round judgment period was short, so we used shallow pools. The judgment periods for later rounds, we actually went to slightly longer. We had fewer runs, but those runs that we did have, and this is important, were still diverse. and they were effective runs. And if they're effective runs, it means that they're finding relevant documents. And so that was good. And I believe, I can't prove this, but I believe that the runs were as effective as they were because of the feedback, right? These systems now had, by the end of the rounds, these systems had lots of training data, the previous rounds judgments. And so therefore the quality of the runs in the later rounds was quite good. The final collection, so if you just want to go get the final collection and not care about how it was built in rounds and things, that has about 70K judgments and 50 topics. And as you'll see in the next couple slides, I think it's actually a pretty solid collection. Here is just to show you sort of what happened. These are the effectiveness scores for, in blue is precision at 5, or except for later rounds when it was precision at 20, or the BPref score in orange, of the top 5 runs by precision at 5, not including manual runs. So this is either feedback or automatic runs, but not the manual runs. And the main thing here is to show as these runs are really quite good. These scores are high. And the reason that we went to precision at 20 in rounds 4 and 5 instead of precision at 5 is because these scores were too good to report precision at 5, because pretty much everybody was getting very close to 1, or all of the better systems were getting very close to 1. And when the scores are that good, they are not good diagnostic, right? You don't learn anything from having just saying that everybody's scores are 1. And so we went to precision at 20 in those cases, in the later rounds, just because the systems were as good as they were. Now, previously, in other TREC collections, if you look at the number of documents that were judged, the percentage of the judged documents that were judged relevant, in previous TREC collections, if that number is greater than about 1/3 or so, the collection is probably not good. And the reason for that is you probably haven't exhausted the relevant documents yet. You probably haven't found most of them. And so therefore the ones that are remaining are probably not like the ones that are found. And so it's probably not a fair set. However, and we have for TREC COVID, we have some topics where almost 3/4 of the judged documents are relevant. That's an extremely high number. And so I was figuring, well, we'll have to throw those topics out. And in the next slide, you'll see that I did some stability tests, like I had talked about earlier. And using those topics in the stability test show that those topics are just fine. And why should that be? Why are they fine in TREC COVID, but not fine elsewhere? And my conclusion, and I have not a whole lot of evidence to actually, I mean, some of this is just speculation on my part. But my conclusion is that the topics are fine for 2 main reasons. One is most of the runs were effective. And so therefore we didn't have a lot of nonsense documents in those pools, right? Because usually in TREC we have runs that just didn't work, and they add to the pool, and you just have all these documents which just nobody cares about. So most of the relevant space, I believe, was explored because of feedback. We also, while the pool depth was fairly small, COVID-19 actually, in terms of document set sizes that we see in TREC, isn't really all that big. And so for some of these topics, we judged 1% of the document collection, and that is an enormous percentage. We're normally at less than 0.1% that we've judged. There are also duplicates in the documents set, and those duplicates would be easily retrieved by feedback. And so that also increases the percentage of relevant that were judged. And finally, the relevant that I used into these tests of 3, 4 included both relevant and partially relevant as relevant. So here's the collection stability results that I alluded to in the past. I mean, these graphs are pretty tiny, and I'm not sure how much you can see, but largely the main thing to see is that if you throw these topics out, these topics that I was worried about that had these 3 so big of percentages, it doesn't change anything. If anything, it makes it worse because it's fewer topics in the collection. And so I stuck with all 50 topics is the take-home message from this slide. I can't look at reusability very much because I don't have runs that use the whole collection, because in building the collection, it was only in the individual rounds. So I don't currently have runs that use the entire collection, and so I can't do the normal sorts of reusability tests that I could do in the past. I could do reusability though in the first round because that didn't have feedback. That was a normal collection. And I looked what happened when I got more judgments for those first round documents. And in fact, the Kendall-Tau scores aren't bad. I mean, the Kendall-Tau scores are actually fine. They're excellent. The maximum drop, there was one run in precision at 5 that dropped 33, and that's that little circled run up there, circled in red. That run suffered from being unjudged in there. But the fact that it dropped so much is actually more a testament against precision at 5. Because if you look at the map scores, even with so few judged, the map scores stay very stable. And precision at 5 is just a very unstable measure. So let me just conclude here. The TREC COVID everything that we did for TREC COVID is archived on this website, ir.nis.gov/COVID submit. And everything here includes the topics, the judgments, all of the submissions, the score reports, and we're also maintaining a bibliography of papers that people write about their participation within TREC COVID. So it's all there. We lack effective ways of assessing the quality of a test collection. And the current state of the practice is we're still looking for a diverse set of high quality runs, and that will help. You can build a good collection that way. And we know how to build collections with a small number of relevant documents, but small has to be relative to the size of the judgments. And we can't know what R is until we've already done an appreciable amount of assessing. And so we're sort of still in a bind there. Okay. All right, so that's it. And I'm happy to take questions.
Any questions from the audience? You can unmute yourself and ask the questions.
Okay, so I see one in the chat here. Will this become a regular track at TREC? No, it is not a regular track in TREC. It wasn't a track in 2020. It was a special thing. And for my purposes, TREC COVID collection is built. There it is. And I am hopeful that we will never have to experience such a thing again in terms of not being in a pandemic to capture it. The paper, the bibliography that we're maintaining, we are maintaining. So as people write papers about their participation, we'll post it to the website bibliography. Presumably we can also post people who didn't participate but who used the collection in meaningful ways, we'd be happy to post those to the bibliography too. But TREC COVID as such is finished. Clay is currently having an ongoing thing that's similar to it though, so you might want to check out the Clay version.
Right. I think there are no more questions for now. Yeah. Thank you, Dr. Lewis, for being here and giving your talk. Thank you.
Okay. Thanks very much.
Yep.
Hello. Surabindu, check the chat.
Yeah, it's done. All right, let's move ahead. So the next is the track presentations again, and the next presentation, track presentation, is on anaphora resolution from social media text in Indian languages. Track presentations. Okay, in Indian languages, fine. Sorry, and the presenter is Sandhya Singh. Is she here? Okay, Sandhya Singh is here. All right. So the paper she's going to present is attention-based anaphora resolution for code mix social media text for Hindi language.
Hello.
Yes, you are audible, Sandhya. Yeah.
Okay. Yeah. Hello. Good evening, everyone. I'm Sandhya Singh from CFILT Lab, IIT Bombay. I'm presenting my paper, which is a submission to share task for anaphora resolution from social media text in Indian language track. Okay. And I'll be presenting my paper and my work based on for this particular track. Let me begin. My co-authors are Kevin Patel and Professor Pushpak Bhattacharya. So this will be the outline of my presentation. So quickly, I'll take you to the basic description of the share task. The task was to identify anaphora and its antecedent in code mix tweet data, tweet text. The data was a mix of Indian languages, so I opted for Hindi-English code mix language tweets. The other languages available were Tamil and Malayalam. The apparent challenges which were to be addressed for this particular task was to address the insufficient context information due to size limitation, because tweet text has the size limitation, which cannot include the context information beyond the limit. Then creative and abbreviated vocabulary which we use in our tweet text. Then hybrid grammar, because we are using a code mix data, and emoticons. So I'll begin with basic introduction to what is anaphora resolution. Anaphora resolution is the process of antecedent identification and linking its anaphor to in a text. Now, what is anaphor? Anaphor is a word that points to the previous reference. Okay, and antecedent is basically the entity to which anaphor is referring to. Like in the example below, we can see like Virat is an excellent cricketer. He is the captain of Indian cricket team. Now here, Virat becomes the antecedent, and he, which is a pronoun, is basically the anaphor because it is referring to the antecedent Virat. Now, what is a code mix text? Now, text comprising of words from more than one language in a sentence can be termed as a code mixed text. Now, mixing can happen at multiple levels. It can be intersentential, intrasentential, or intra-word as well. You can see in the example below here, like looking at this tweet, it's very difficult to say whether it is primarily English or primarily Hindi, because it's a mixture of both the languages along with some abbreviation which is happening at a in inter-sentence level as well as the intra-sentence level, along with the emoticons in between. Now, the challenges which are posed by this code mixed text is creating spelling variations. For example, we give our own spellings to the words to give more emphasis. Abbreviations which we use, people are really creative with their abbreviation of the word. Some of the examples I have mentioned is great and before. Then transliterated text like bank wale loan denge. Like this example here, it's written in, it's basically transliterated form of Hindi language. And the hybrid grammar, because when the two languages are mixed, which grammar to follow, and emoticons. So these are some of the challenges which are apparently posed by the code mixed text. Now, this approach which I have experimented with is, I have tried to use a GRU-based encoder-decoder model with attention architecture. The model consists of one encoder layer and two parallel decoder with attention. The attention is programmed to focus on antecedent data values. Now, decoder 1 focuses on the antecedent span start index, because the antecedent spans can vary from one word to 5 to 6 words. So that span needs to be addressed properly. So one decoder was focusing at the start of the span index, and decoder 2 was focusing at the end of the span index. Now, the data set was provided to us by the TREC organizers, and the data was Hindi and English language mixed with data, which was given to us in a Connell format, which is a column-wise format. The statistics of the data is mentioned here in the table. We had a training set of around 810 documents, from which we had separated 100 documents for the validation purpose, and remaining documents were used for training purposes. The test set was comprising of around 1200 documents. So this is just a sample of the input data given to us, where the first column was having all the words or tokens. Second column was having the mentions to the antecedent and anaphora tokens, and rest all was mentioned as empty tokens. And antecedent link was mentioned wherever there was an antecedent link available. Now, the pre-processing steps which we use for this task is, since it was a mixture of Hindi and English, though Hindi language text doesn't require lowercasing, but English required, just to normalize the text, we lowercase the entire data set. Then emoticons and symbols were removed, because in anaphora resolution, we realized that emoticons may not be playing much major role. Then all the text HTML entities were substituted with their actual punctuation symbol. Twitter ID and all the URLs were removed, text was tokenized. Then we inserted some special tokens, that is root and end of the sentence, to mark the beginning and end of the document. Now, data preparation for input to the model was, we included antecedent span information in a specific manner. So two columns were added to the text document as antecedent index start index and antecedent end index. In the added columns, each word in the document is mapped to the root token, which is at index 0, and except the marked anaphora tokens. Like wherever there is an anaphora token, only that token was marked to that specific index. Rest all the words were marked to the root token. Similarly for the antecedent span end index column as well. Then we also added the part of speech feature to each and every document, which, because part of speech can assist in anaphora linking and identification. So this was the final input which was given to our model for processing. Here you can see the cluster start index and cluster end index along with the part of speech feature was added. Now this is the basic block diagram of our model which we have used. Here you can see we are using like in input text document, part of speech feature is included. Both were converted to a embedding format, then concatenated together. Then GRU-based encoder and two parallel decoders were used for start and end of the index. The model configuration consisted of, we used a custom word embedding of 150 dimension trained on the data available was data which we had. Part of speech feature was integer encoded. Variable length input was padded with the maximum length of 80. 100 GRU units for encoder and decoder layer were used. And model was trained for 100 epochs with early stopping feature. And we used weighted loss coefficient for loss computation purpose. The model was trained for 4 different hyperparameter configuration. These are the configurations where the models differed from each other. We mainly made the variations in the loss functions which we were using, and the weighted, because we are using the weighted coefficient for the attention feature. These are the weights which were used, and the learning rate. The model attention output. So we did not focus on the model output, but we focused on the model attention output and map it back to the tokens for the pronoun pause tags only. The model output was evaluated for precision recall and F measure. These are the results which we obtained for each of the configuration. So here we can see that we are having a low recall value, but with relatively high precision value in the validation and as well as in the test set. So this basically tells that though the model is not predicting many correct, anaphora values, but whatever it is predicting is the correct one. Most of it is correct. In the end, we all know that anaphora resolution is a challenging problem in NLP. And with our approach, we could get an F measure of 0.21 for code mix text for Hindi and English language using our attention-based encoder-decoder approach. These are some of the references which we have used in the paper. That's it from my side. If any queries, I can answer.
Any questions from the audience? All right. Okay. Thank you, Sandhya.
Thank you very much.
Okay. So next is the track presentation, the RCD track presentation. And the presentation is actually a pre-recorded video that was sent by the participant, and we are going to play that now. So the next presentation is DCU at the Fire 2020 retrieval from conversational dialogues RCD task by Abhishek Kaushik. Yeah, I request Bhargav to play it. All right, Bhargav.
I'm going to represent DCU and Ed Center in Fire 2020 RCD challenge. So the overview of today's presentation is I'm going to talk about the motivation, why we do this challenge, and what is the problem statement, and what are the approaches we use to do this challenge, what are our results, and what is our takeaway. Let's talk about the motivation and objective. In conventional search systems, a person do a single shot query. He did a query and then get a relevant results, read about the relevant result, and try to satisfy the information need. And to satisfy this information need, which is the main objective, we do multiple passes of search, reframe the query again and again. So reframing the query to get the most relevant result increase the cognitive load. Reading a lot of documents to satisfy your information need again increase your cognitive load. And a system has a performance pressure that one single shot should bring out all the relevant results. Again, it can bring a load on the system. So to avoid those type of challenges, a concept came into existence, that is conceptual dialogue-based IR system, where there is an intermediate agent, or you can say a dialogue manager, which will handle the communication between a user and the information retrieval engine and try to support user in the query reformulation, in the query search, confirmation of the query, and providing some sort of assistance in the search process to ease the process of search that can reduce the cognitive pressure on the user. So the problem statement. Now, when we talk about conversation between an agent and the user, is there any way to extract the information need? Is there any way to really extract or contextualize the data, what user is looking for? So in task 1, there are a set of dialogues which is given by the organizer of RCT, and we have to understand and try to figure out our approaches that can we figure out the way to extract the information need or the query. Basically, for this task, we did 2 approaches, approach 1 and 2. The first approach was because we thought like from the conversation, if we can extract some important keywords. For that, we have to monitor the important lines from the dialogue. So we use some sort of summarizer. There are 4 types of summarizer we used in the approach 1. And after that, we use keyword extraction method. For this task, we use 2 keyword extraction method. One is text rank, based on the very famous algorithm. And the second is YAKE, that's a statistical method to extract important keywords. Now, approach 2, because we want to investigate that if we are not using any sort of summarizer, because there might be information loss. If we are passing the whole conversation and extracting important keywords from the whole conversation, is it going to make any difference? So we want to investigate approach 1 and approach 2. In task 2, it was majorly based on task 1. Whatever information need you extracted, those information need you are going to use in task 2 for retrieving relevant documents. The organizer has given us a Wikipedia document, which is around 73 GB, that is being indexed by a proprietary API. And we use the standard, very famous retrieval model, that is BM25. To investigate more on information need, we just select one retrieval model here. Now let's talk about both the approaches in task 1. In task 1, suppose this is a conversation as you see in the figure. This conversation has been passed to the summarizer. There are 4 types of summarizer model, as I mentioned earlier. There is some sort of parameter tuning which we did with the summarizer, changing the percentage of summary or changing a threshold window. And then we pass the important sentences or the important summary to the key phrase extraction method. There are 2 key phrase extraction methods, that is YAGE and text rank. Those extract important keywords. Again, there is also parameter tuning in key phrase extraction based on the fields, how many times the word repeated, what is the window and the importance of words. Different parameters are there based on each method. And after that, we selected the best information need from that particular conversation. In task 2, we eliminate the summarizer because we want to investigate. And secondly, we also afraid that we might lose information because of using summarizer. What will happen if we pass the whole conversation to a key phrase extractor? And after doing some parameter tuning, can we extract the best key phrases from that conversation? So these 2 approaches we want to investigate. And for those approaches, we use 5 model. Actually, we did 50 models. And after that, we selected 5 models based on the blue score and J-cut coefficient. And these are the 5 models which is used for trained data, and these models are applied for test data, and the results were sent to the organizers. Now we also, while doing the investigation of 50, there are 2-3 important factors. As I say, this algorithm may have multiple parameters, and we tried a lot of parameters, and the detail of those parameters are well defined in the exam, well defined in the technical notebook of this particular task. But the 2 major important factors was word length and the phrase frequency. These are the important scenarios in extracting the keywords. Let's talk about the first model, that is Y7. We went to the BERT base. This BERT base summarizer is based on the Hugging Face. Hugging Face API use or convert the summarizer into features. Those features are being clustered by k-mean algorithm by using a Python API that's called extensive summarizers, and then we use Yake method to extracting the best keyword from the summarizer. Yake method is a statistical text feature extraction method to select the most relevant key phrases. After that, we tried another model that is F8, and we have keep on changing the summaries here. Keep on changing summaries, keep on changing word length to select finest model from that configuration. In this, we use our custom model where we use TF-ID of high scoring sentences based on TF-ID. Then we use dbScan algorithm to cluster them, those clusters, and those clusters has been then there's a cosine similarity has been calculated from the clusters and the movie name. And after that, we selected the best percentage of the clusters, and then those clusters have been passed to the text strength method to extract the best keyword. Now the text strength is a very popular method, and it is used by the Python API called PyText. This text strength method is an algorithm to extract the essential phrases by constructing a lemma graph to represent link among the candidate phrases from the summary. Similarly, we use F7 method where we use Kullback-Leibler method. This is a greedy-based algorithm which will add the sentence to a summary as long as it decreases the KL divergence. And the phrase extraction method will remain same, the text strength. And similarly, we use Loon, quite famous method for summary extraction. And the last page, if you see F5 model, we don't use any summarizer. We directly pass to the text strength to extract the best keywords. Now our results are, based on the test data, the best result is F84, which is our own custom model, which is built in the lab, which show the best promising results. And the corresponding promising results, we try to replicate, and those information need, we pass through the in task 2 for retrieval of best results. And there, this Y7 F74, okay, this model, which is using KL and text strength method, proved to show more result based on MRR. So what are the takeaways from this particular RCD challenge? First of all, we figure out the keyword frequency and the word length is important. Conversational length, if there would be more dialogues, we can do some sort of advanced deep learning model to train the model, but the dialogues are limited, so it could be important scenario. TF-IDF still is important for extraction and query extraction. Query extraction is a challenging task. We have to explore more methods to extract the best queries. And we cannot ignore the incremental learning from dialogue. Basically, when people talk, they learn from each turn. So we have to figure out that method for incremental learning, step-by-step learning. And the fact is, retrieval relevant document majorly depend upon the right query. And similarly, that's why the task 2 was completely based on task 1. Hope you enjoy this presentation. Thank you for listening.
Right. So we next move towards the next track presentation. The next track presentation is on fake news detection from Urdu in Urdu language, and the next presentation is on the paper, and the paper is Urdu fake news detection using generalized autoregressors by Abdullah Faiz Rahman Khilji.
Oh, 1 minute. You can start now.
Hello, am I audible?
Yes.
Okay, hi everyone. Today I'll be presenting on the Urdu fake news detection using generalized autoregressors. So in this presentation, I will be covering the introduction, the related work, the data set, the system description, the results, conclusion, and future work. So first, beginning with the introduction. Moving more and more of a life to the virtual world, the importance of detecting fake news has increased manifold as it is proven to have a negative impact on our society. And the spread of fake news is really exponential, and any initial attempts to could greatly help in curtailing the issue. So our work mainly focuses on the fake news detection of the Urdu language. In this work, we have considered the task of fake news detection as a binary classification problem. We have used ExcelNet, which is based on a generalized autoregressive pre-training for language understanding to train our models. The monolingual corpus for the Urdu language was developed by us, which gives the pre-trained model an impetus for various downstream NLP tasks in the Urdu language. Our work is based on a dataset and a task provided by the organizers of the 2020 fake news detection in the Urdu language. Now, coming to a brief related work, very few works have been done on fake news detection on the Urdu language in the past due to the very less availability of the requested dataset for this. For the given Urdu fake news detection task, the only available dataset is of Amjad et al. Works like Ghichano et al. And Ghenem et al. Uses emotional cues in the text to detect fake news, and these are some related works. Now coming to the dataset that we have used. For our work, the organizers of 2020 fake news detection in the Urdu language task provided us with the dataset for fake news detection. They have manually collected and annotated the dataset for this binary classification task. The trained data included a total of 638 samples, 350 from real and 288 from fake. The evaluation set included a total of 262 samples, out of which 150 were real and 112 were fake. The test set comprised of 400 new samples. We have created our own Urdu monolingual corpus for pre-training the deep learning models, and we have prepared the dataset by extracting Urdu sentences from various sources, including web pages, blogs, books, and government websites. The resultant monolingual data obtained contains about 11 million sentences. For pre-processing the dataset, the organizers had already pre-processed the dataset for the classification task. So we had to only process the monolingual corpus that we had extracted, and we have used the Urdu hack tool. The pre-processing step included the removals of URLs, email IDs, and mobile numbers. It contained a lot of URLs because we used different websites to crawl and scrap the data. The text was also normalized. Space was added after the punctuation marks and extra spaces were removed. Diacritics were also removed along with normalizing Urdu characters to obtain the text in proper Urdu Unicode range. Now for the system description, we have pre-trained the model and then fine-tuned it. The model was pre-trained using the ExcelNet. The BERT-based architecture was not used as it tends to corrupt the input with masks, as it does not consider the dependency between the masked positions. And the BERT model had a discrepancy between the fine-tuning and the pre-training step. And similarly, we have used the ExcelNet model for pre-training. It employed a generalized autoregressive method that takes the advantage of both pre-training objectives, autoencoding, and the autoregressive language model. The ExcelNet model integrates the recurrence mechanism and relative encoding scheme that improves performance in tasks involving longer sentences, like the given task of fake news classification. Because one fake news document contains a larger text than normal classification problem. For fine-tuning the pre-trained model for the main binary classification task, that is to detect whether the news is legit or fake, we have followed the fine-tuning procedure of BERT as given by Yang et al. A span-based prediction is employed wherein a fixed length is sampled and consecutive span of tokens are randomly selected as prediction targets. The problem of pre-trained fine-tuned discrepancy is also solved here. Now coming to the results. Results for the fake news detection task was declared by the organizers of the 2020 fake news detection in the Urdu language. Overall, 39 teams participated and our team CNLP and ITS, as shown by the overall results on the website. For the fake class, 0.83 precision was given,
And for the real class, we had shown our system had shown a precision of 0.84. Now coming to the conclusion and future works, our automated fake news detection system adopts the generalized autoregressors technique for the binary classification problem. Even though our XLNet based model shows good results, there are avenues for improvement as the monolingual corpus can be improved. It's currently small now, and the improved monolingual corpus can be used for further downstream NLP tasks, and several architectural improvements can also be made. Thank you.
Any questions from the audience? All right. Okay. Thank you, Abdullah.
Thank you, sir. I'll stop sharing.
Yeah. All right. So the next presentation is on learning models for Urdu fake news detection by Fazlur Rahman.
Hello.
Yeah, you're audible.
Thank you. Good evening, all. I hope everyone doing well. My topic is learning model for Urdu fake news detection. Since just now a good background and introduction has been given by Abdullah or Abdurrahman Faizur Rahman, I guess. So I'm not going to give a second introduction on this. Just I'm going directly to my proposed learning model and our results. So as we know, researchers have explored several learning models for task of text classification and fake news detection in rich resource languages such as English and German and such languages. But therefore, some of these learning models have been explored. It means very less learning approaches has been explored for research poor languages such as Urdu or Indian language or Persian language. So in this work, I was explored some learning models such as machine learning, deep learning, and transfer learning. So for feature that I have used in these models, I have used Ngram features, combination of Charingram and Wordengram for machine learning models, and I have used pre-trained word embedding for my deep learning model, and also as for transfer learning as a pre-trained language model for Urdu language was available, have used. So first I'll talk about my machine learning algorithm I have used. I experimented different various machine learning classifier on Ngram features, but among them I got multinomial naive Bayes and MLP, and also logistic regression were getting best results. So I used them to ensemble and create one voting classifier based on hard voting configuration. And this is my first machine learning model that I used a countervectorizer to convert this extracted feature to vectors that can be fed to our ensemble classifier. Also, deep learning model, whenever we are talking about deep learning model, means we are talking about neural network, and we are talking about word embedding, and as there were available some pre-trained word embedding, I have used this word embedding. I have tokenized my data set, training data, and then I built word index dictionary, and then embedding matrix using pre-trained word embedding. So I use a multi-channel neural network, that configuration I have given here. Then after training, this will be my second model. Also, A third learning model is transfer learning. Has we know in transfer learning is nothing but just using two deep learning model, something like that. That here we are transferring the knowledge we have gained from first model to second model. Fortunately, as a general domain learning model, language model was available, I skipped this part and just I transferred language model knowledge to my target task, that was a binary classification for fake news detection. So also I have built one hybrid text classification model by combining all this learning model, such as machine learning model, a deep learning model, and also ULM fit. Uh, First, I have cleaned my data, and here I have given my pre-processing steps. So, like unnecessary characters such as @, hash, and hashtag, and this thing I have removed, and I have removed the stop words and all after pre-processing. And the generate first I have trained my all three models actually. Then I use majority voting for all three learning models. So now I have submitted 3 rounds. I didn't submit deep learning as in my training, except before submitting I was getting not much good results, so I skipped that one, and I submitted separately machine learning model, ensemble of machine learning model, and also transfer learning model based on using fast A library I have created based on architecture proposed by Jeremy Harvard for English. Actually, he has not, but I use Urdu language model, and I applied for Urdu fake task. Also, HTC model, or high hybrid text classification model, that is a combination of all these 3 learning models I use, and based on majority voting I have obtained this result that it shows first model, machine learning model, maybe because even task organizer use I think char engram I also use, but I combined with the word engram, and I obtained my best pair formats and ensemble model. And also, if you want one comparison with existing model, you can see that is something in middle, and we need to improve our model. And I'm thinking of adding a fine-tuning my deep learning model, one step of fine-tuning my word embedding, then applying for my neural network. And also for machine learning, we are going to use a different feature or feature selection method I'm going to apply. And also for transfer learning model, you can try for use some other fine-tuning, one step of fine-tuning before applying. And as a future work, I'm going to apply my this model for different low resource languages, such as for my native language, Baluchi, Persian, and Indian language. And this is end of my presentation. If you have any question, I can answer.
Right. Any questions from the audience?
Any question?
Okay. Thank you. Thank you for the.
Thank you.
Yeah. Okay, so that brings us to the end of day 2 of FIRE 2020. We meet again tomorrow at 5 p.m. IST, and before that there will be a session of Women in Information Retrieval. There will be a workshop on it at 11 a.m. IST. So yeah, and tomorrow there will be 2 invited talks by Professor Paul Clough and Professor Adam Weiner, and there will be the long paper presentations and some track presentations as well. All right, so see you tomorrow again. Thank you everyone.